Ladies and gentlemen, our VIPs are now entering the event hall. Please give them a big round of applause. A round of applause, everyone. The VIPs are now entering the event hall. Ladies and gentlemen, distinguished guests and esteemed participants, good afternoon and welcome to the Global Spectrum Management Forum 2025, hosted by the Central Radio Management Service. It's truly an honor to have you all here today. My name is Yu Soo-min, and I have worked in the English broadcasting and radio industry for several years, so it is an absolute honor and delight to have you all here today to serve as our MC for this meaningful event. Now, before we begin, please set your receivers to channel 1 for Korean and channel 2 for English. Now, to kick off today's program, let's take a moment to watch a short introductory video about the Central Radio Management Service, which is the host of this meaningful event.
ICT infrastructure powers all digital innovation. The invisible force behind everyday life. At the center of Korea's hyper-connected digital future, CRMS ensures national security and everyday happiness. Since 1947, CRMS has grown into Korea's spectrum authority, backed by strong systems and expertise. With expanded roles in broadcasting and mobile communication, CRMS now oversees Korea's digital infrastructure. CRMS builds a clean and smart radio environment. A nationwide network of CRMS monitors Korea's radio spectrum in real time. We license and inspect radio stations, crack down on illegal radio stations, tackles every single case of radio interference anywhere as fast as possible. The Satellite Radio Monitoring Center safeguards Korea's space spectrum and national satellite communication networks. CRMS is ready for digital disasters, ensuring digital infrastructure remains secure and supporting swift recovery. We inspect critical digital facilities to prevent service disruptions, protect national communication networks, and conduct drills for emergency response. We detect radio interference in maritime, aviation, and GPS systems, alerting the authorities. CRMS protects users and keeps markets fair. We stop spam and block numbers used in digital crimes. We crack down illegal devices and enforce electromagnetic safety. CRMS strives for communication and cooperation. We work with global partners, support Korean tech abroad, and empower universities with resources and expertise. Radio education programs for children. Nationwide amateur radio direction finding competitions. Cybersecurity support for small and medium enterprises. On-site service centers reaching out to the public. We'll be a trusted guardian of our digital world. A global leader in radio broadcasting and communications, CRMS is with you every step of the way.
Well, ladies and gentlemen, we hope this video has helped you with a better understanding of the Central Radio Management Service and its key role in spearheading the development and safeguarding the nation's digital infrastructure. Of course, so let's officially open today's conference. To officially open today's forum, we will begin with the welcoming remarks by Mr. Jun-Ho Choi, Director General of the Central Radio Management Service. Ladies and gentlemen, please join me in welcoming him with a big round of applause.
Ladies and gentlemen, good afternoon. I'm Jun-Ho Choi, Director General of Central Radio Management Service at the Ministry of Science and ICT. It is my great pleasure to welcome all of you to the Global Spectrum Management Forum 2025. For joining us today, despite busy schedules, I would like to extend my sincere appreciation to Mr. Heung-bo Jung, Vice President of the Korea Radio Promotion Association, Mr. Wael Syed, Chairman of ITR Study Group 1, and Professor Il-gyu Lee from Gongju National University. My heartfelt thanks also go to all representatives from spectrum management authorities in Egypt, Bangladesh, Botswana, and other countries, as well as to all domestic and international participants here with us. Today, we stand at the center of a major transformation where foundational digital technologies such as AI and big data, together with emerging radio frequency-based technologies like drones, autonomous driving, low Earth orbit satellite communications, the IoTs, and 6G are reshaping every aspect of our society. These technological innovations not only open new services and industries, but also call for stronger international cooperation to ensure the efficient use and management of the radio frequency spectrum. At this forum, we will share national experiences and policy directions through diverse topics, including AI and big data-based future spectrum monitoring technologies, management of low Earth orbit satellite services, TV white space technologies, and EUM 5G, Korea's customized private 5G networks. Through these discussions, we aim to build a safe and efficient spectrum environment together. In particular, the radio spectrum is now recognized not merely as a technical resource, but as a vital public asset that drives digital transformation and social innovation. As this importance grows, international solidarity and cooperation have become more essential than ever. I hope today's gathering will serve as a starting point for designing a responsible spectrum management framework for future generations. The Central Radio Management Service has been dedicated to maintaining national spectrum order and strengthen global cooperation since its establishment in 1947. We have signed MOUs with 16 countries to share spectrum management experience and actively participate in international organizations such as ITUs. I sincerely hope this forum will further strengthen networks of trust and cooperation among nations and lay the foundation for a sustainable global spectrum ecosystem. Finally, I would like to express my deep gratitude to all staff of the Central Radio Management Service and partner organizations who have worked hard to make this event a success. I wish today's forum to be a meaningful occasion, full of insight and inspiration for everyone here. Thank you very much.
Well, thank you, Mr. Junho Choi, for your inspiring words and setting the stage for this momentous occasion. He especially emphasized the importance of global cooperation in spectrum management in the midst of technological innovation, which is why we're all here today. Of course. So next up, we will hear congratulatory remarks from Mr. Jung Hoon-bo, Vice President of the Korea Radio Promotion Association. Ladies and gentlemen, please welcome Mr. Chung with a big round of applause.
I will speak in Korean. Good afternoon, ladies and gentlemen. As introduced, I am Jung Hoon-bo, Vice President of RAPA. At the outset, allow me to express my gratitude to Director General Choi Jun-ho of CRMS for hosting this event. I also extend a warm welcome to our distinguished guests for being here out of your hectic schedule. Especially, we are joined by many eminent radio spectrum management experts. So, actually, our keynote speaker, ITUR Study Group 1, Wael Syed, Chair, should deserve my recognition. Plus, Naifa. And also, I have been invited from RAPA, and also my special thanks go to experts from Asia, Africa, and trainees from other countries who are invited by RAPA. I welcome all of you to this 2025 Global Spectrum Management Forum. And 5G, 6G, and wireless communications and IoT and convergence technologies are critical infrastructure for spectrum management, and this is an invisible asset. These serve as a foundation for digital innovation. Recently, AI and satellite communications are emerging as a new technology which increase the demand of the spectrum, as well as it varies the way we use the spectrum. In this ever-changing environment, managing spectrum more efficiently and intelligently has become a critical challenge that all nations around the world must address together. Today's forum represents a meaningful opportunity to collectively explore solutions to these challenges. For our part, the RAPA has been steadily advancing international collaboration projects in the spectrum field through close collaboration with industry, academia, and governments. We particularly hope that this forum will serve as an opportunity to strengthen practical collaboration networks among major countries in Asia, Africa, and beyond, while further expanding linkages with the international spectrum community, including ITUR. And I do believe this forum will serve as a meaningful platform to map out the future strategy of managing spectrum. And in closing, I'd like to express my appreciation to all those who have worked tirelessly to organize this event. Thank you very much.
Well, thank you, Mr. Chung, for your warm and encouraging message congratulating the opening of this event. He especially highlighted the growing significance and also the need for effective management of radio spectrum in this era of digital transformation. Well, next up, it is my absolute pleasure to introduce today's keynote speaker, Mr. Wael Syed, Chairman of ITUR Study Group 1. Today, he will deliver a keynote address on the topic of shaping the future of spectrum management through AI. Ladies and gentlemen, please give them a big round of applause.
Thank you, Jasminida. Thank you. Ladies and gentlemen, good afternoon. Distinguished colleagues and friends, it is a true honor to be here in Seoul, the city that stands as living symbol of how technology and collaboration can shape a better world. Allow me first to express my sincere appreciation to the Ministry of Science and ICT, Mr. Junho Choi, the Director General of Radio Management Service, and Mr. Hwangbu Cheong, the Vice President of Korean Radio Promotion Association, for giving me this privilege to join you at the Global Spectrum Management Forum for 2025 year. Actually, Korea's commitment to the innovation and cooperation has made it a bridge between regions, and it's fitting that we meet here today to discuss how technology and trust can guide our shared future. This year's forum provides an exceptional platform to explore how artificial intelligence and human expertise together are shaping the next chapter of the global spectrum management. AI represents not only a technological evolution, but a new mindset, one where data becomes dialogue and becomes prevention and innovation becomes inclusion. This forum is more than an event. It is a shared space where science meets policy and where our common responsibility outweighs our individual differences. We are living through a period of profound transformation. Spectrum, once treated as a purely technological resource, has become a strategic asset, the foundation of economies, security, and inclusion. And today, artificial intelligence is beginning to redefine how this finite resource is planned, shared, and protected, turning spectrum management from a reactive process into a proactive, data-driven science. AI-powered analytics can uncover hidden patterns of spectrum use, detect anomalies in milliseconds, and simulate complex sharing scenarios that were once impossible to visualize in real time. With the rise of 5G, 6G, IoT, and non-terrestrial networks, the demand for spectrum has never been greater. But while technology expands infinitely, spectrum does not. We are all, quite literally, sharing the same invisible frontier, and that shared space demands shared stewardship. Ladies and gentlemen, now where is this shared challenge more visible than in the sky above us? In just a few years, we have moved from a handful of satellites of tens of thousands orbiting the Earth, connecting communities, empowering innovation. But with these new opportunities come new complexities. The same orbits that can connect us can collide. The same frequencies that empower us can interfere. And the same ambitions that drive innovation can also drive competition. Among these complexities lies a growing concern that rapid deployment of low Earth orbit constellations that sometimes move faster than regulations meant to guide them. When technical and operational parameters are not fully aligned with the national regulations, the result can be legal uncertainty and even erosion of public trust. Regulatory harmony is not a barrier to progress. It is foundation of sustainable progress. Only through coordination and compliance can LEO constellations deliver on their promise of universal connectivity without compromising national sovereignty or safety. This also calls for building strong national capabilities to monitor spectrum, verify and evaluate the behavior of LEO systems in real time. Here again, artificial intelligence can play a transformative role. Automating detection, predicting interference, and empowering regulators to act with the precision and speed. We are in many ways witnessing a new space race. Nations and corporations alike are competing for orbital slots, for spectrum, and in some cases for influence. As space becomes more crowded, the risk grows that the very system designed to bring the world closer could push it apart. The question, therefore, is not who will win this race, but how we will coexist in a way that preserves both opportunities and order. Ladies and gentlemen, spectrum does not recognize borders, yet policies do. Every region, every administration has its own priorities and pressure. But the signals that travel through our airwaves do not stop at customs. They move freely, indifferent or geography or ideology. This is why the governance of a spectrum can't be a zero-sum game. It is and must remain a collective responsibility. If competition overshadows cooperation, we risk fragmentation. But through dialogue, transparency, and trust, we can build the global framework where innovation thrives without conflict. In today's session, we will hear valuable insights from Korea's experience in national spectrum management to emerging monitoring technologies and to the global cooperation efforts that define our future, our shared future. The way we manage spectrum today will determine not just who connects, but how fairly we all share the benefits of connection. Before we look ahead to the next World Radio Communication Conference, it's worth reflecting on another frontier that's rapidly taking shape, the role of artificial intelligence in spectrum management. AI is no longer a distant concept. It is already helping administrations monitor, predict, and optimize frequency use. Machine learning models can detect interference patterns, forecast congestion, and support dynamic spectrum access in real time. Yet, this journey will be a long one. The foundation must be carefully laid from technical standards and data governance to ensuring that automation always serves transparency and trust. AI should not replace regulators. It should empower them. It should make spectrum management faster, fairer, and more foresighted. This is precisely where ITUR Study Group 1, what I have the honor to chair it, can play a leading role. The group's ongoing work under question ITUR 241/1, titled Methodologies for Assessing or Predicting Spectrum Availability, provides a natural framework for integrating AI-based approaches and a structured and globally harmonized way. By starting here within Study Group 1, we can lay the ground for intelligent systems that assist regulators, strengthen the compliance, and enhance the fairness and the efficiency of a spectrum use worldwide. This is where the International Telecommunication Union, ITU, is particularly Study Group 1 for the radio communication sectors, plays its vital role. Study Group 1 brings together regulators, researchers, and engineers from every region to develop the principles and methodologies of spectrum management, from planning and monitoring and to sharing and compliance. Through this work, Study Group 1 produces the recommendations, reports, and handbooks that guide national administrations, and it's also support capacity building and knowledge sharing for developing countries. Today, Study Group 1 is pioneering studies on AI-driven monitoring, predictive analytics, and automated coordination, innovation that show how technology can strengthen trust, transparency, and efficiency in spectrum governance. I would also like to recognize the strong and consistent participation of the Republic of Korea in these activities, particularly in spectrum monitoring and emerging technology studies. Your experts have made valuable contribution to our recommendations, reports, and collaborative experiments, helping bridge a gap between theory and practice. I encourage our Korean colleagues to continue expanding this engagement and to keep inspiring us all with leadership and innovation in the years ahead. In many ways, Study Group 1 is the laboratory of collaboration where science meets regulation and where the future of global spectrum management quietly takes shape. Ladies and gentlemen, the spectrum can connect us, should never divide us. As we look toward the future, let us remember that the invisible waves carrying our voices and our dreams belong to no one and to everyone. Let us look the skies above us as bridges, no battlefields. Let us build a world where connectivity is guided by responsibility, where innovation is driven by inclusion, and where intelligence, both human and artificial, serves cooperation. For the true promise of AI lies not in replacing human wisdom, but in amplifying it, creating a future technology listens, learns, and leads with humanity. Together, as one community, we can shape the future spectrum management through AI, through trust, through unity. Thank you. Jasminida.
Well, thank you, Mr. Saeed, for your insightful keynote speech highlighting how artificial intelligence is redefining spectrum management from automation, optimization, monitoring, and data analytics for smarter regulatory decision-making. It seems like we are really entering a new frontier with the power of artificial intelligence. Just like I said, I think innovation is inclusion. I think that was the punchline. All right, ladies and gentlemen, this concludes our opening ceremony. So we are now setting the stage for a group photo session. We would like to commemorate this meaningful gathering with a group photo featuring our VIPs, esteemed speakers, and esteemed participants, overseas participants. So we kindly invite everyone to come out to the front, to the stage for the group photo. Please stand at the front according to the number on your nameplate, please. For the group photo, please check the number on your nameplate for the group photo session. Please come out to the front and join us for the group session, ladies and gentlemen. Ladies and gentlemen, please come out to the front and join us for the group photo. VIPs, esteemed speakers, and overseas participants, please come out to the front and join us for the group photo session. Let's commemorate this meaningful occasion for the group photo. Well, for the first photo, let's just smile and look straight to the camera, please. Smile, please. Let's relax, everyone. Give us a big smile and stand and look in front of the camera. Look to the camera. Yeah. Raise your arm, right arm. With some extra power and vibrance. All right. Are we all done? Thank you. Thank you so much. And thank you, audience, for your patience. Thank you for participating in this group photo, and thank you for your patience, the audience, for Thank you for your patience, and we will move to the next session shortly. All right. All right, looks like everyone is now seated, so it's time to move on to our next session. So our first session will delve into the topic of Korea's spectrum management landscape. We do have an exceptional lineup of speakers who will provide their in-depth expertise on this subject. Our first speaker is Mr. Hyun-Soo Kim, Deputy Director of the Radio Planning Division at the Central Radio Management Service. Today, he will present on the topic of the current status of spectrum management in the Republic of Korea. Ladies and gentlemen, please welcome him with a big round of applause.
Good afternoon, ladies and gentlemen. As introduced, I am Deputy Director Kim Hyun-soo from Radio Planning Division, and this year marks the 5th edition of Global Spectrum Management Forum. Spectrum management requires global collaboration. So I do believe this forum will lay the foundation for better understanding of each other and for strengthened international cooperation. Now let me touch upon the spectrum management of Korea. And this is the rundown of my presentations: radio wave management organization, radio wave management status, and future tasks. Now you are seeing the organizational framework for spectrum management in Korea. Central agencies include Ministry of Science and ICT, which oversees the planning of spectrum management, as well as affiliate organizations include CRMS, which is responsible for execution of radio management, and National Radio Research Agency is responsible for EMC evaluation, and relevant organization includes KCA, which is responsible for radio station inspection, and RAPA, Radio Promotion Association, responsible for supporting the broadcasting companies, and TTA is responsible for standardization of communications technology. Next, organization of CRMS. CRMS is nationwide organization, and there are 5 divisions under headquarters, and there are 10 regional radio management stations, including Satellite Radio Monitoring Center, and we are responsible for spectrum management around the nationwide. And authorized personnel is 854, and budget is 893 billion Korean won. Now, this is utilization procedure of radio management, and there are 3 steps: securing radio resources, allocating radio resources, manage radio resources, post allocation. The Ministry of Science and ICT is responsible for international allocation, and then in domestically there are frequency assignment, frequency designation, frequency usage according to its usage. For efficient allocation of radio resources, CRMS was responsible for radio station licensing, frequency usage survey, and also in managing radio resource post allocation, we do radio station inspection, including government, military, broadcasting radio station, interference monitoring, interference response, electromagnetic field strength measurement management, and RRA is responsible for electromagnetic compatibility evaluation, and KCA is responsible for radio station inspection, excluding the central radio management offices. Now, let me touch upon the key responsibilities and roles of CRMS. So, licensing and inspection of radio station, radio monitoring, interference response, radio jamming devices, investigation and enforcement against illegal broadcasting and communication equipment, public communications, and collaboration. This is our umbrella category of radio sector, and we hold this forum for better international exchanges. And also, our roles are expanded to safety inspection of critical communication facilities, disaster response for ICT infrastructure, protection of ICT user support for information security of SMEs. Now let me touch upon the status of radio wave management. So radio station licensing is to establish and operate a radio station requiring review and authorization. So applicants are evaluated for frequency assignability and technical requirements to prevent interference. If it's met eligible, then we license and we give green right to operators to operate their stations. And also it includes reporting, simplified establishment of stations with no need for frequency and power restriction. So this is all about simplicity of application. It includes receive-only stations and providing telecom services, for example, mobile communications. And frequency approval is all about specific frequency usage permitted for national defense, security, foreign affairs, major international events. And licensing or reporting exempted when there are lower power emitters. It includes Wi-Fi and Bluetooth. Now let me touch upon the procedures of licensing. Operators apply for the applications and CRMS reviews it to determine eligibility, and then after being authorized, operators go for installation and completion inspections are carried out by CRMS, and then operators can operate their radio stations. And you can refer to the tables with regards to the number of radio stations. A radio station inspection is to confirm compliance with technical standards and operator assignment for licensed radio stations. There are four major areas. Completion. Is all about inspection of technical conformity when radio facilities construction is completed after license being granted. And regular inspection is all about regular inspection of radio equipment performance within a 5-year cycle. Modification inspection is to inspect for verification of performance when transmit power or other licensed parameters are changed. And occasional inspection is for ships or aircraft prior to departure abroad when performance verification is required. And CRMS includes national agencies, military broadcasting radio stations for inspection, and KC carries an inspection for all radio stations other than those under CRMS. Now, radio monitoring. Radio monitoring utilizes radio monitoring system to ensure legal compliance and address interference from terrestrial, marine, and aerial sources. If there is an interference, then we identify the source of interference. To be detailed, illegal radiation detection is to detect illegal radio waves and unauthorized radio stations, and radio station operation monitoring is to ensure that licensed or registered radio stations operate within their approved scope. Radio quality measurement is to identified characteristics such as frequency deviation, occupied bandwidth, and spurious emissions. Marine and aviation communication monitoring is to monitoring communications, particularly distress and emergency communications. And satellite and international radio monitoring is for compliance with IT regulations and registration data for domestic international satellite signals in the region between 55° east and 160° west longitude. This is all about to ensure efficient and lawful utilization of radio waves. For your reference, CRMS. You are now seeing the radio monitoring equipment. There are 130 sets for fixed systems and 40 sets for mobile system to measure the spectrum. And also, we identify illegal frequency detection, radio quality measurement. And there are third generation system to be built and in operation. And also, compared to the previous one, GPS and direction identification are equipped for better performance. And spectrum monitoring system is developed in Korea, and Onpum is building and maintaining those spectrum monitoring equipment. And also for the satellite system, 3 sets, 6 fixed, 2 sets mobile. And also Korea's spectrum management system should be built. So by 2026, 7 sets will be built. Next, interference response. So, interference response is to create a safe radio usage environment to prevent interference and disruption amid increasing demand for spectrum. So, those satellite SRMC is kept and up and running 24/7. So it is swiftly identify the source of interference with active responses. So there is a liquid of radio waves and EV charging. It create disruptions in mobile identifier, and also their terrestrial radio stations can be disrupted as well. So we swiftly look at the source of interference with swift responses to eliminate the sources. Now let me touch upon the radio jamming devices. Authorization and reporting of radio jamming devices for responding to illegal drone activities and national key facilities. So these radio jamming devices are not allowed. However, for the security and safety of the critical infrastructure, so it is necessary to establish radio jamming devices as non-lethal means to protect national key facilities and respond preemptively to threats. And jamming devices are characterized with 3 types. First one, jamming high-power radio waves are emitted to block communications between operators and drones, interfering with GPS signals and making the drone uncontrollable. This is the first types of radio jamming devices. Second type is a control seizure or spoofing, hacking the drone's control signals to take over the drone's operations. Third one is drone dome spoofing, sending fake GPS signals to cause the drone to move outside of its intended area. Now let me touch upon the investigating and enforcing against illegal broadcasting and communication equipment. Manufacturers, importers, and sellers of broadcasting and telecommunications equipment must undergo testing that complies with the standards specified in the Radio Waves Act and obtain conformity assessment certification. Equipment that has not undergone conformity assessment is subject to criminal penalties, fines, and corrective actions. So conformity assessment test commissioned to the private sector is for wireless EMC standards and details for EMC. So actually those RA will take a deep dive into this, so I will skip it through. Now this is the future tasks. AI-based spectrum management for efficiency. So we try to build AI-based spectrum management platform. AI is used to increase the performance through the use of advanced technology, maximizing spectrum management. So we'll be proactive in managing spectrum, and also we accumulate and analyze the spectrum big data for optimization of those data. And autonomous vehicle, 5G communications technologies are our basis for us to build smart city factories and next generation mobilities UAM and autonomous shipping without any spectrum interferences. So this requires us to swift detection and responses to interferences. So this requires us to build AI-based spectrum management platform. So we do our best to establish this platform with allocated budget. This ends my presentation. So I do believe this forum will be productive to you. Thank you very much.
Well, thank you. Well, thank you. Thank you, Mr. Kim, for sharing a clear overview of Korea's current spectrum management landscape and also the organization's extensive roles. He covered allocation and utilization processes, policy directions, and the efforts to improve efficiency and sustainability in frequency use, not to mention a host of other supervision and management activities of the organization. Thank you. So, following the first presentation, we are very much pleased to invite Mr. Jong-seung Wang, Assistant Director of the ICT Conformity Assessment Division at the National Radio Research Agency. He will deliver a presentation titled Introduction to Korea's Conformity Assessment System and the Current Status of Mutual Recognition Arrangements. Please welcome him with a big round of applause.
So good afternoon. My name is Jong-seung Wang of the National Radio Research Agency. I had to rush here because I was kind of late, so I may be a little bit rushed in my presentation.
Global Spectrum Management Forum 2025. My name is Jong-seung Wang, and I am in charge of global cooperation at the National Radio Research Agency of Korea. I am great honor for me to stand here as a speaker at the meaningful forum. Today, I will speak on the topic. My presentation will cover four main parts: Korea's conformity assessment procedures and MRA, how we respond to new technology in testing and certification, future outlook and proposals for global cooperation, and finally, a brief conclusion. Now, let's begin with our overview of Korea's conformity assessment system. The term conformity assessment may sound complicated, but simply put, it means checking whether a product meets the required standard. In Korea, conformity assessment system is carried out mainly under the Radio Act to ensure safety, reliability, and a healthy use of radio spectrum.
Due to technical difficulties, we will have another presentation slides that matches his speech. So please, we ask for your understanding. There was a little technical difficulty. We will switch to presentation slide and commence on the recommence.
Sorry.
Apologies.
Okay.
Right. Let's start again. Please, Mr. Wang.
Now, let's begin with an overview of Korea's conformity assessment system. The term conformity assessment may sound complicated, but simply put, it means checking whether a product meets the required standard. In Korea, conformity assessment is carried out mainly under the Radio Act to ensure safety, reliability, and healthy use of radio spectrum. There are four main types of conformity assessment: certification of conformity, legislation of conformity, supplier declaration of conformity, and interim certification. Certification of conformity applies to devices that may cause serious interference or risk to radio environment, such as smartphone, Wi-Fi routers, Bluetooth earphones, radar equipment. The procedures is as follows. Manufacturer or importers send product sample to designated testing laboratory. After passing the required tests, They submit documents such as test reports, manuals, and circuit diagrams through our online system. Once the review is completed, the certificate of conformity is issued by the National Radio Research Agency with a unique identification code. This complete is the official certification process. Legislation on conformity applies to devices with a low level of risk, such as low power wireless device, fax machine, IP cameras, and computers. In this case, suppliers obtains tester reports from a designated laboratory, then directly registers the product information online. Once the legislation is approved, the system immediately issues a legislation certificate, which allows the product to be placed on the market. Supplier's declaration of conformity applies to devices with very low risk, such as USB devices and lighting equipment. Manufacturer or importers test the product themselves or through a designated laboratory, and then prepare a declaration stating compliance with the standard. This declaration must be kept available for inspection, and the product's information must be posted online. Interim certification is granted when standards are not yet fully established. For example, in case of new IoT devices or converged medical devices using novel communication technologies, applicants can request this certification based on international or self-developed standard. And after review, the National Radio Research Agency issues a temporary certificate to allow early market entry. All categories certified products must be displayed the CASE mark and the identification code clearly on the product. Through this system, Koreans ensure both the safety and reliability of ICT devices, while protecting the radio spectrum environment. This is the effect of MRA. MRA means Mutual Recognition Agreement. Without MRA, overseas testing and certification cost a lot of time and money. If we apply the MRA, we can test and certificate domestically in Korea. As the result, the period is reduced and cost is saved. Next is the MRA process. It is divided into the page 1 and page 2. In page 1, we test domestically, but we must get certification from an importing country. In page 2, both testing and certification are complete domestically. Therefore, page 2 is much faster and simpler. Korea has MRA agreement with following the countries. Canada is one country that has both page 1 and page 2 agreement. Now, let's move to a more exciting topic. How technology advances such as artificial intelligence and Internet of Things and 6G are reshaping the testing and certification industry. In the past, testing mainly focused on whether a product worked properly. Today, we must ask, is it safe? Is it secure? And in the future, we'll go even further. How intelligent is it? How well does it connect with other devices? Imagine, for example, an AI speaker suddenly ordering strange item on its own, or an autonomous car being hacked and driving to the wrong destination. It sounds alarming, but it is no longer science fiction. This is why the paradigm of testing and certification is changing. Artificial intelligence, AI, can improve testing efficiency by automating process and predicting potential failures. But at the same time, we must also test and certify AI itself, its fairness, transparency, and reliability. In short, we must ensure trustworthy AI. The Internet of Things. As all devices become connected, the risk of cyber attack increases. Therefore, testing must go beyond individual devices to increase overall network security. Digital transformation and remote testing. The COVID-19 pandemic showed us the value of remote technology. In the future, remote testing, digital testing reports, and online certification processes will become standard. However, we also raise new challenges, such as preventing data tampering and ensuring the reliability of remote procedures. Looking ahead, I believe we are moving toward an era of intelligent, integrated security certification. Future certification will lead to evaluate not only product function, performance, and safety, but also cybersecurity and AI ethics. To achieve this, global cooperation is essential. By working together, sharing information, harmonizing standards, and expanding mutual recognition agreements, we can reduce the duplication and prepare for future challenges. This is why today's gathering is so meaningful. Korea has world-class ICT infrastructure and technology, and combined with your expertise and experience, if you any question after my presentation, please feel free to my email. Thank you. Thank you very much your kind attention.
Well, thank you very much, Mr. Wang, for sharing your presentation. He let us learn more about Korea's conformity assessment system and also walked us through this very complex mutual recognition arrangements. Well, ladies and gentlemen, let's give him a big round of applause.
Thank you.
All right, so for the final presentation of session 1, we are very much pleased to be joined by Mr. Tae-wook Hwang, team leader of the EM5G business team. He will present on policy framework and case studies of private 5G here in Korea. Ladies and gentlemen, please join me in welcoming him with a warm round of applause.
안녕하십니까. 방금 소개.
As introduced, I am Hwang Tae-un. So we do have simultaneous interpretations. I will speak in Korean. Please tune to channel 2 for English. So I am working for KCA under the bigger umbrella of Ministry of Science and ICT. I am leading the 5G private 5G in Korea, which is EM5G business. So I'd like to touch upon the current status and the use cases of private 5G. As you are fully aware of, I'd like to introduce to you the private 5G, EM5G, and advantages of private 5G, and what are the use cases in Korea. So private 5G needs no introduction. However, this is the ultra reliability low latency communications, and also it has ultra reliable low latency communications, enhanced mobile broadband, and massive machine type communications are all allowed. So EUM. It reads EUM in Korea. EUM has two different meanings. It is number one meaning is connected or connectivity. So in Korea, private 5G, its core service name is EUM Service 5G. Multiple devices are connected in a holistic manner. So private 5G offers communications of that. This is the name, the meaning of the name of EUM. So private 5G in Japan is referred as local 5G. Private 5G basically leverages on commercial 5G's advantages, but unlike this, private 5G is able to offer private network in building premises. So it uses 5G technologies, but it has its own private network, unlike the commercial 5G broadband. So existing 5G network and private 5G network are having some differences here. So existing commercial 5G shows high speed and reliability and stability in communication, low latency as well. But it has disadvantages. So it has the uplink and downlink ratio. This is a higher ratio of downlinks. When it comes to Wi-Fi, it has low-cost wireless network usage with multiple API calls. It has a wider coverage. This is advantage. However, low reliability and secret threats are two disadvantages of Wi-Fi. And multiple devices are connected to API. It results in lower speed. And private 5G leverages on 5G advantages, which includes mobility, reliability, and security. But also uplink downlink designing is well carried out by users on their request. So industrial usages such as manufacturing and logistics, private 5G has been built on their request. And 4.72 to 4.82 gigahertz and 7.9 bandwidth is used for private 5G. European nations, other nations, so European nations 3.5 and 3.7, but Korea uses for 4.7 gigahertz and 1 megahertz is allocated, and 28 gigahertz, 200 megahertz is allocated, so 50 megahertz multiplied by 12 blocks, and for 4.7 gigahertz, 10 megahertz and 10 blocks. What's critical here is that in service areas, RSLP minus 105 dBm, so this is used beyond that, and at the boundary minus 105 dBm. This is our regulation. And if there are two different 5G service areas overlapping, then there should be coordination area serving as a buffer, and RSLP minus 105 dBm or higher. This should be the RSRP standard, so that the coordination target area is to prevent the interferences with the two different frequencies. Private 5G around the world has higher expected growth. So according to 2024 Global Market Insight, private 5G CAGR is expected to be registering at 40.5%. And private 5G companies with those experiences are surveyed, and they have multiple expected outcomes. So collaboration with workers is significantly enhanced, which is about 92%, and carbon footprint will be reduced 79% responses, and productivity increase 75% response, and cost reduction 73% responses, and worker safety is ensured 65% responses. Perfect 5G is applicable in manufacturing industry and other industries, so it has higher advantages. So in manufacturing industry, manufacturing robotics or conveyor belts, automation require wireless communications. So Wi-Fi is the basis up until now, but if it will be replaced with private 5G, then it has a higher advantages. So this slide deck shows the two differences of Wi-Fi and private 5G. So Wi-Fi, so 54 Mbps of speed, and private 5G is maximum of 20 bps, actual 1 bps, and the number of devices is less than 10 because of the slower speed, but device connection per AP for private 5G 20K or more, and latency for 5G 1 to 200 millisec. Private 5G shows 10 to 20 millisec, so it is relatively lower latency for private 5G. When it comes to download speed, it shows clear distinctions between the two. And intermittent reconnection issues, and especially frequency interference, 5G is higher for that, but per 5G has its own properly allocated frequencies, so no or very low possibility of frequency interferences. But when you look at the cost of installation, per 5G is outnumbering that of Wi-Fi. So LG Electronics in Korea tested advantage of private 5G compared over Wi-Fi. So over 8 weeks, private 5G AMR7 devices and Wi-Fi based or connected AMR4 in the same area, they compare those two devices and it shows the comparisons. So number of communication without AMR location data, AMR moves in the certain space, so while movement, AMR reports its localization, but number of communications without AMR location data, private 5G, one time for 8 weeks, Wi-Fi 1055 times over 8 weeks. It has missed out on location data of AMR. And time for missing location data per 5G 1 sec, only one time. When it comes to Wi-Fi, 6,356 sec missing time. So distance without data reporting. So they fail to upload their locations onto the server. Distance without data reporting 0.7 meter for private 5G and 4,449 meter for Wi-Fi. And number of bottlenecks 0 observed for private 5G, while 29 for Wi-Fi. This is the test data done by LG Electronics. So this data teaches us that private 5G cost is phenomenal. However, we need to go for the private 5G replacing Wi-Fi for as an enabler to robotics in manufacturing industries. And now let me touch upon the private 5G use cases in Korea. There are higher expectations, and by 2030, 1,300 sites will be the private 5G, and at a maximum of production inducement effect is $2.75 billion. And now let me change the gear toward the private 5G use cases in Korea. Say Hyundai Motors is now using private 5G. It has plant in Korea and in the States. And this slide shows the US plants of Hyundai Motor. Hyundai Motor Group, as you can see on your left photo, so it's a robot canine, and this robot moves around the plant to inspect the integrity of assemblies of parts, and it also identifies the errors of manufacturing with AI vision. So 50 robots are deployed onto the floor, and it uses AI vision for error detection, and the doors are assembled to the body, and also the torque is important. So the AI vision is used to the torque of nuts and bolts so that it can also detect the errors out of that. And on your bottom, AGV robots are used. So previously, conveyor belts are built upon the ceiling, but now these AVG models are used to carry the vehicles. This is the landscape of the current Hyundai Motors US plan. It is running based on private 5G. And the similar platform is also under establishment for Ulsan factory in Korea. And also it is used in shipyard and port. So this is a shipbuilding application. The pictures are might small, but the conveyor belts is automated based on private 5G network. And in the shipyard, there are many layouts to be updated in real time, and this layout should be confirmed. So private 5G is allowing 100 megabytes to be downloaded and results to be uploaded in a faster manner. And LG Innotek, Korean company, is using AI Vision, AGV, AMR, digital twin based on private 5G. And Korean Aerospace is a five jet manufacturer, and it also uses private 5G for better security and smart workplace. And Hyundai Motor, as I mentioned before, and POSCO, they use private 5G for crane automation. I touch upon the use cases of private 5G and the current status of private 5G.
Presentation showing how Korea's private 5G networks are driving industrial digitalization, enhancing efficiency and productivity through a well-thought-out policy frameworks and also some practical use cases. Thank you so much for your comprehensive presentation. Well, ladies and gentlemen, you might be a little bit tired, sleepy right now. It's time for a well-deserved 15-minute coffee break. So please take this opportunity to network, share ideas, and do some recharge. You can freely stretch, do some stretching, and we will be back in 15 minutes. Okay, thank you so much. Well, welcome back from the break, everyone. Hope you're feeling more energized and refreshed after a short coffee break. Feel free to do some stretching, have some coffee for more energy. Right, so let's start session two. In session two, we will explore some latest technologies shaping the future of radio spectrum management. Our first speaker is Mr. Kim Kwang-ui, Research Officer at the Satellite Management Division, Satellite Radio Monitoring Center. Today, he will present on the topic of LEO satellite monitoring planning. Ladies and gentlemen, let's give him a big round of applause.
네.
Good afternoon, ladies and gentlemen. My name is Kwang-hee Kim. I'm a research officer at Satellite Management Division, and I will speak in my native tongue, Korean. I understand that we have many guests from Asia and Africa, and I want to thank you for joining us here today. And it is truly a pleasure to join you here today in this forum. Well, globally, I believe that this is an excellent opportunity to introduce Korea's LEO satellite monitoring system. I'll be covering three things today. I'm going to give you a very brief introduction to SRMC, our center, and then I'm going to talk about some of the monitoring activities. I'm also going to be very short, but I am going to go long or in detail about the plans that we are creating here in Korea for the LEO monitoring system. So about 3 decades ago, where Korea was building its own independent GSO system, satellite system. So that was back in 1995, I think. And so we realized the importance of the spectrum of management. In 2002, we have built a system to monitor GSO satellites. So Korea was the fifth country in the world to have a system to be able to monitor GSO satellites. And then 7 years later, along with the GSO satellites monitoring, we have established a system to do a mobile satellite radio monitoring. So that was back in 2009. And I believe that it's 2010 that the NGSO satellites have become registered with the ITU, and also a lot of services related to NGSO began to be provided. So that is why in 2013, we realized the importance of the NGSO satellite system. And so in 2016, we have completed our NGSO satellite monitoring system. And then back in 2018, in order to do more systematic monitoring, we have been able to build what's called a geolocation system. Now, we are under phase 1 of the LEO monitoring system. And this LEO monitoring system will be completed by next year. And so let me move on to the second topic, which is the satellite satellite spectrum management over Korean Peninsula. And so our monitoring range, as you can see, from E55 to W160. So E55 would be Seychelles Islands, and W160 would be Hawaiian Islands. And so on the Korean Peninsula, there are about 120 GSOs are hovering. So 8 of them are Korean satellites, and about 113 are foreign satellites. So we have two systems here. One system is to monitor Korean systems to see if the signals are coming down properly, and also whether there are any sort of radio interference. And another system that we have, we monitor about 113 foreign satellites on a regular basis. We check their signal quality. And these are 120 satellites which we monitor. And so Korean satellites are at 113 and 116 degrees. And these are the satellites are used for broadcasting as well as communication purposes. And 128 degrees, there are two satellites, and they are Chalian 2A and 2B. And Chalian 2A satellite is a meteorological satellite, a very important satellite. And so it would be, for 24 hours, will monitor or detect the weather system on 24 hours and provide that information. And Chalian 2B would be we'll be checking the environmental pollution or the marine pollution status. And then this is about the NGSO. So besides the LEO, these sort of satellites, these NGSO, they would pass over Korean Peninsula for about, on average, about 15 minutes. And we would monitor these satellites in real time. And there are about 690 of such satellites, but we are not, this does not include LEO satellites. And we began to discuss about introducing LEO monitoring system from 2023, and I believe that end of this month we will actually will be monitoring the LEO satellites. And there are about 4 monitoring systems for the NGSO satellites that are currently in operation. Excuse me. So in case of monitoring station number 3, and then we have, like tracking antennas for the other systems, and for each band, they would monitor in real time the NGSO satellites. And the hottest issue right now would be related to station number 5. And so the antenna, the diameter is about 10 meters. And so it has a system limitation to monitor LEO satellites. And that is why we are actually building a system to monitor LEO satellites separately. I think it was back in 2020, when the changes began to occur very quickly. And so we began to move, from GSO to LEO satellites. And I believe that there are 4 reasons for such transformation. In case of GSO satellites, well, there's a limit in terms of speed, and the bandwidth is small, and also there's also a long delay time. And so it does not allow for broadband communication. And LEO satellites will be able to make up for those shortcomings of the GSO satellites. And second thing is that, LTE, the 5G terrestrial networks, where in case of Korea, compared to other countries, like a large continental countries, Korea is small in terms of land mass. And so the 5G network or the LTE networks can be used anywhere in the country. But in case of large countries, they would have limitations in setting up such a terrestrial networks, and it would also cost quite a lot. And so from what I remember, there are only like 40%, only 40 to 5% have of the terrestrial or the GSO network, and the remaining of 50% or the 60% would have blind spots. So in order those 60%, whether it will be covered by a GSO or NGSO, that would be the choice. And then the third reason is the technological advancement with the emergence of SpaceX. So the satellites have become cheaper or less expensive to use. So that was a transformational technology. And so through this technological advancement and enterprisal of innovation, now it's become possible to launch satellites at a low cost. And the fourth reason would be government and companies such as SpaceX or Amazon Kife. These private companies, these sort of private companies began to enter into this market. So these are the 4 reasons or the 4 trends that beginning from 2020, the satellite operators are saying it's time for LEO or satellites. Well, SpaceX, by Elon Musk, now enables us to use communication services with the satellite services that's provided by Elon Musk's company. Another trend that I would like to talk about is related to terminals. Well, in the past, the antennas, they were parabolic antenna, but now we have flat antenna. And the second trend is that in the past, in order to communication, we needed to have a satellite dedicated terminals. Now we can use our own smartphones in order to be able to communicate. Does this mean I only have 2 minutes to go? And this means that There are currently about 9,000 LEO satellites, and by 2027 there will be about 27,000 LEO satellites, and by 2030 there will be over 50,000 LEO satellites hovering over the Earth. And we believe that it's 2027 where there's a drastic increase of the number of LEO satellites. That is why that we need to be able to monitor these satellites by 2027. That is why we have the plan to be able to monitor such a satellites by 2027. So let me explain this. And this is from SpaceX. So the receiving angle is at 30 degrees. So and about 50 satellites are flying over. And these 50 SpaceX satellites are sending signals to the terminal. So how are we going to monitor these 50 satellites that are hovering over the Korean Peninsula? So that has been our task. As you know, LEO satellite, in terms of frequency, it uses the latter frequency band that used to be used by GSOs. And so and this is quite well described by the relevant regulation. And so NGSO should not provide interference to GSO. That is the most important thing. And also LEO or LEOs. The EPFD by the LEO shall not exceed the limit given by the table, as you can see, from 22-1A to 20-1E. So we have incorporated these two conditions in our planning for the LEO monitoring system. And so if the terminal is going towards the north, there is less interference. But these, it faces the satellites, that's going to the south of the peninsula, where there is a higher potential for the interference. And so Korea's LEO monitoring system, well, we began to work on it in August. And so the system currently mainly has hardware like antennas. So I'm talking about these antennas. In case of here, so there are two types of antennas here, including tracking antennas. And on the left-hand side, it's just one antenna that is tracking. And here's the flat antenna. As I said, there are 50 satellites that will be passing over the Korean Peninsula. And when they pass through the Korean Peninsula, they will be sending the signals. And through this antenna here, for 10 milliseconds, we will be capturing the signal. And so utilizing this antenna at the bottom, we will be able to detect these signals from the LEO satellites. And all of this has to occur within 7 seconds. For SpaceX, when they pass over the Korean Peninsula, according to our simulation, it can send signals for about 7 seconds, which means this antenna should be able to capture that signal within the 7 seconds. And the antenna on the left-hand side, in order to measure the EPFD, and it's fixed at 113 and 116 degrees, so that so we will be able to check the changes in the signal power or the signal of fluctuation. So probably next year, I will be able to present you the actual results of the operation. But this is what's going to happen anyways. So there will be you see 50 satellites are passing over. And of those satellites, we'll be able to detect which satellites are sending signals to Korea. So with this tracking antenna, we will be able to track this signal, these radio wave signals. And all of this will have to be done within 7 seconds. And so this is the task that we are currently carrying out, and we are doing this with a local Korean company. And next, I want to talk about how to measure EPFD. And this may be the most critical task in this project. And we also we have done research in order to come up with a solution to measure EPFD. And I am confident that we will be able to have a system that will successfully measure EPFD. This is a project. I'm presenting for the very first time in public, and I hope that my presentation today will help you, those that are involved in the satellite monitoring. Thank you.
And an insightful overview of the rise of LEO communication services and, of course, Korea's planning for LEO monitoring system. It seems like it's a critical step for ensuring stable communication environments and also ensuring effective frequency management in the new space era. And just like I said, it seems like it's truly a next generation infrastructure. All right, why don't we move to the next session, next presentation. So this time we will hear from Mr. Kang-hee Kim, Principal Researcher at the Radio Research Division at 3D Communications Research Laboratory, Electronics and Telecommunications Research Institute, or E3. Now his presentation is titled Considerations for Future Radio Spectrum Monitoring, Data-Driven Expansion and Cooperation. Ladies and gentlemen, let's welcome him with a big round of applause.
So I will say hello to you in Korean. So we are joined by many VIPs. So I prefer to speak in Korean. So we do have simultaneous interpretations, but this is a global forum. That's why I speak in English. So there might be some details not to be explained because of my English proficiencies. Please reach out to me after my presentation. I will answer to you.
And thank you for joining this session. I'm Kang-hee Kim from Metro Korea. Today, I would like to share our consideration on the future direction of spectrum monitoring in a rapidly changing environment, especially data-driven expansions and cooperations. It is one that is not about replacing what we do, but evolving how we think of it. In this presentation, we will see a framing of future spectrum monitoring. The ideas presented here are not the only path forward, and however, the stages and viewpoints shown are practical way to explore different technical approaches. And I hope it helps you to identify where your current methods stand, see what comes next, and consider what else matters in advancing spectrum monitoring. Please enjoy. First, let's quickly review the three fundamental roles of radio monitoring. First is ensuring order and safety by verifying compliance and detecting removing harmful interference. Second is protecting national security and sovereignty, which involve preventing unauthorized intrusion and tracing illegal transmitter. Third is analyzing the efficiency of use to analyze inefficient usage and enable resource reallocation. However, the spectrum environment is changing rapidly. The emergence of LEO, UAM, massive IoT, and DSA, we are facing the difficulty and complexity in spectrum monitoring. Operational environments are also changing. Decreased manpower necessitate the remote and automated operations. There can be different level of automation, but what we want is an automated operations. As we all know, AI has become a trendy tool empowered by the rapid increase in computing power and the advent of GPU. However, the critical point is that AI cannot function without the three core requirements: model, training paradigm, and data. AI offers powerful tools, but we should not think of it as a cure-all for every problem. We must heed the cautionary note: AI is not panacea. It's from Gemini Google. AI is a tool, not a guarantee of an intelligent solution. It can fail if inputs are poor. Garbage in, garbage out. The output quality is fundamentally limited by the quality, quantity, and bias of the training data. The problem of explanation exists, and not a replacement for domain expertise. Phew. And there are some overfitting and generalization problems. So let's keep in mind that we need to keep thinking about how to utilize this effectively without facing the same kind of problems. Why is AI an indispensable tool despite not being a panacea? It is precisely to close the gap between rule and reality. Rule-based systems are excellent for static compliance, but lack the ability to predict dynamic interference. Yeah, please look at the simple fact checker. If a power is larger than X, then alarm. Here, this is a very good expression for compliance test. But if we think about, we use this kind of things for getting dynamic threshold in spectrum monitoring, we have to change this threshold to X. Fortunately, so far, we have done this X adaptively from the current situations. But usually that kind of things was done by non-deep machine learning. But we are talking about deep machine learning too. So on this page, the key point is that AI may offer the intelligence to handle complex environment changes. Before moving on, let's take a moment to clarify the difference between automation and intelligence. automation execute repetitive rule in place of humans, increasing speed and efficiency. Intelligence conversely involve model-based reasoning, handling uncertainty, and focusing on judgment. So intelligence can understand situation, have to understand the situation, and judges, predict, decide. So what you're pursuing is intelligent automation. Not only automation, not only intelligence, we're pursuing intelligent automations. Maybe we can do this intelligence automation by combining data-driven learning with adaptive logic. But let's keep in mind, not all AI equals high intelligence. Actually, we want high intelligent automations. From now on, I will talk about pursuing intelligent automations. I will show you why automation imperative and some example evolution roadmap and strategy. Why is automation imperative? To expansion of LEO, UAM, and V2X mandate continuous automated monitoring. It's too harsh for human monitoring, too much, too complex, too costly. Even with the nationwide systems and complex protocol analysis, the amount of monitoring data would be far beyond what human can process. It's about scale and scope. For scope, enabling global coverage required real-time tracking and interference mitigation beyond the human capacities. And also, in some case, hopefully, we can process terabyte per day from thousands of sensors continuously. And there's a safety issues for this. It's essential for securing ultra low latency, uninterrupted spectrum for UAM and autonomous driving. So this chart most clearly illustrates the necessity of automation. Manual analysis process only 5 to 10% of raw data. In contrast, automated monitoring approaches near 100 data utilization. Automation is the key to enabling near total data utilization compared to limited manual throughput. To re-emphasize, rule-based systems are effective as fact checkers for static compliance, but it's weak against the unprecedented complexities. AI provides the necessary intelligence through multi-source fusions, multimodal patterns. We need some adaptive loop. Let's say we're training machines for one purpose. The trained machines can inference an action and should be evaluated and have feedback to the training. We need that closed loop for the systems. So So AI is the platform and toolkit enabling the continuous adaptive intelligence, enables that adaptive loop, inference, action, evaluate, and feedback to the training. We propose a roadmap that divided the maturity of spectrum monitoring into 4 stages. It starts from stage 0, legacy local system, moves through stage 1, the primary centralized rule-based operational model, and progress towards stage 3, autonomous federated learning cloud. Notably, in stage 2 and 3, AI's role expand to edge inference, central training, and global fusion through federated learning. Here are key takeaways summarizing our discussion so far. First, automation is non-negotiable. The scale of LEO, UAM, V2X, such things mandate continuous automated monitoring. Second, AI provides the required intelligence. Rule-based system, mere fact checkers. AI is the predictor and adapter. Third, the future is hybrid and collaborative. Theory must merge with learning and edge inference with cloud training. Actually, about the legal framework, we will talk about in the cooperative spectrum monitoring systems. It's just short of time. There are some checkpoint here. Is when you think about AI powered spectrum monitoring automations, you have to check this AI life cycle stages. Usually it's composed of 7 factors, but we divide it into 4 groups as its relevance. So, yeah, please check the point. And the last part is about establishing cooperative spectrum monitoring systems. Moving beyond technological solutions, I now present the strategic framework for future radio management, the CSMS. I would talk about 2 important pillars and 1 strategy abstract and make a conclusion. Apart from what's shown in figure, the Spectrum Management Agency has been consistently working on to promote efficient use of radio frequencies. It's likely that this work will continue going forward. Please take a look at the pictures. You can see some devices here that at any given moment could be involved in situations where people's lives are on the line. Let's revisit the need for CSMS. The dynamic, wide area nature of modern service like LEO, UAM, and massive IoT has exceeded the capacity of the static fixed point monitoring systems. It's not easy to carry out deep and continuous radio monitoring in such a complex spectrum environment as shown in figure. New technologies keep emerging and building the infrastructure needed for constant monitoring requires heavy investment, man and systems. That's another big challenge. So there need to be strategies. CSMS really comes into play when rely on information from direct radio monitoring becomes too expensive, inefficient, or just not enough to keep people safe. The main idea is to get the kind of data that's hard costly to collect on our own by using information from service operator or pulling it from other field systems. To do that, for CSMS, there are basically two key components. One is law and regulation, and the other one is data and platforms. In the law and regulations, it's the framework. The core goal is to ensure regulatory compliance and national spectrum sovereignty in globalized environment. And pillar 2 is data and platform, the intelligence. Core goal is to enable proactive prediction and autonomous decision support using collaborative intelligence. These two pillars are reduce regulatory uncertainty, cut mean time to recovery, and maximize the spectral efficiency. There can be two different groups, each with their own interest. It's about rules, sovereignty, and versus business interest. So national sovereignty needs strict output control and domestic law compliance and want to access minimum operational data. But in the business side, business interests want uniform and simplified global operation for viabilities and protect their secret. So in the intersections, we need a resolution for this. So if we make if we implement a mandatory system level agreement defining minimum essential data for sharing and establish legal liability for interference caused by LEO service and provide clear path for technical review and resolutions. Yeah, this is this diagram illustrates 4 levels of data fusion hierarchy. Yeah, I skipped this one. And this slide details the data source regulate action and monitoring benefit for each of 4 support levels. It's about data strategy. What kind of data we can get and what kind of data, how we use that kind of data depending on the level. The key is moving beyond the level 1's rule-based analysis using regulated sensors and to using service-operated data, level 2, and third-party platforms, level 3, and embedded sensing, and level 4, to enable proactive risk assessment and situational awareness inference. In summary, rule-based systems are essential for legal compliance and level 1, but AI learning systems drive adaptation and predictions in level 2, 3, 4 by effectively correlating multi-source, multimodal inputs. The synergy between them is key. For example, correlating AIS ship location, its level 4 information with coastal satellite-based mobile network or just a mobile network operator traffic, it's a level 2. And regulator sensor data from our own is level 1 to preemptively identify unlicensed ship transmission. Sorry for lush. Here's a conclusion. We propose 3 strategic next steps. First, integrate collaborative monitoring into regulation. Cooperation must be regulatory prerequisite, not a voluntary afterthought. Second, establish a mutual trust platform to facilitate data sharing, not data ownership transfer. Third, invest in dual pillars, both technology, cloud-native AI platform, and regulation, bilateral data sharing agreement. Our mission is to evolve monitoring from measurement to analysis, from isolation to cooperation, from rule-based validation to intelligence predictions. By combining technology and trusted frameworks, we can safeguard national sovereignty while enabling a smarter global spectrum ecosystem. Thank you.
Well, thank you, Mr. Kim, for emphasizing the importance of data-driven spectrum monitoring and CSMS, which will be the key in adapting to the evolving radio environment. So he kept emphasizing that AI is not panacea. So we have to wisely and strategically utilize the power of AI to pursue this intelligent automation. So that's the key takeaway, I guess. So next up, we have another last presentation for session 2. Lastly, for session 2, we welcome Mr. Ho Sang-yu, CEO of InnoNet, who will deliver a presentation titled Global Deployment of TV Whitespace Technology. Ladies and gentlemen, let's welcome him with a big round of applause.
네, 반갑습니다. 인원의
Good afternoon, ladies and gentlemen. My name is Ho Sang-yu. I'm the CEO of InnoNet. I'm going to talk about TV whitespace technology. I'll talk about the cases of the TV whitespace. And TV whitespace, but in the developing countries, they want it for a faster connectivity. However, in advanced countries, they want a TV or white space for disaster management. And so if you have any questions after my presentation, please contact me at this email address or phone number. Well, let me introduce our company, where we actually, TV Whitespace was first developed at EDTRI in Korea, and back in 2013 we have received technology transfer from EDTRI, and since then we have been advancing the technology. And back in 2016, and there was a voucher project, and so with that we have received a technology related to smart village. And back in 2023, we did a project with EDTRI, and this was related to the procurement government. So because EDTRI was the one that gave us the technology, EDTRI joined us in the pilot project in countries such as the Republic of South Africa and Colombia and Tanzania. So we did this joint project in 2023. And so we worked with EDTRI when it comes to technology. And when it comes to new technology, you need something like a regulation sandbox to try the technology. And so in 2019, utilizing the regulation sandbox, we used this technology on the cruise ship. And then usually TV whitespace cannot be used underground, but with Hyundai construction company, we have actually, through the regulation regulation sandbox have been able to apply TV white spots space, and so the project has been progressing so far so good. And here in Korea, where the humanoids and the robots have become quite popular, and so because you need. So we have asked for a regulation sandbox for these robots to be used in the underground. That is, we're going to get the approval maybe next month. And our company, TV white space, the speed is not so fast, and so we have two devices, but those two devices had the speed was not satisfactory, and so we want to have like a 70 mega and 140 mega devices, and so we want to apply this on the robotic dog and humanoids. So that's what we'll try to do next year. And globally, about 3 billion people want, 3 billion people need internet access. They don't have that. And also it's quite costly, to provide such internet services to the people in the rural and the mountainous regions. And there's also the issue of, when disasters happen. And that is why TV white space is needed, because it can help to satisfy these requirements. And so TV white space is utilizes temporarily and spatially empty channels in the DTB band, and also it allocates available channels from TV white space database server based on GPS. And so it has advantage when it's used for the communication, and it also has a long range, and it also has a advantage in terms of the invisible range. And the video you need like a 2 megabytes, but when it's like a 26 or the 40 megabytes, those can be transmitted using the TV white space, and the antenna gain is quite low. So it can be used for many mobile devices. And TV white space, there are like 17 SPDs. When utilizing TV white spaces, it can actually solve 2 problems related to UN SDG. And if you look at our TV white space, it can be used in the cities, in the countryside, also in mines, also in times of disaster and war. And we have fixed type TV white space device. You have a lot of IoT devices. They have all different interfaces, and so we have TV white space, that can support Ethernet, the Wi-Fi, also the USB, as well as DC 12V. So we provide many different types of IoT interfaces, so it can be connected to many different types of terminals. And about CCTVs, the securities are quite important. We are able to add security-related modules, and that is why our TV white space can be used in many different types of IoT devices. And about the public safety, for devices to be used for public safety, it has to be able to move quickly. And so we have backpack Wi-Fi and the backpack type of base station, or the trails, or the fire engines. So we have mobile type of base stations that can be used for our TV white space. And so we have a patent for the backpack type of TV white space. It's the patent is actually registered in many different countries, including China and the United States. And the third thing I want to talk about is related to regulation sandbox. TV white space is based on GPS, and therefore cannot be used underground because you cannot get the signals there. But with the support of the Korean government through this sandbox, we have actually tried this out. about underground. So humanoids and robots can be used, are tested underground. And next one's related to AI servers and app. We did not really want to develop them, but we focused on connectivity, but the customers, for them to be satisfied, they have to have many different types of services. And one example, we have something called optimization. Sometimes, the radio waves are not able to be captured. And you have a mountain, so whether you have trees there, if the mountain is flat, depending on that landscape, sometimes communication is impossible or not. And so whether it's the spectrum environment, whether it's the device problem, it's difficult to know what the problem is when there's not good communication. So we have a server that can map where the services are available. And also we have a certification server for the billing purposes. And so we have, for us to do business overseas, well, we have learned that they don't have a free Wi-Fi. Something has to be built. So there has to be invoicing. And so if you're going to the TV white space, we do have that many different servers and apps to be able to provide different services. That is why we do development of the servers and apps. And so we believe that TV white space is going to continue to grow, and it's going to focus on rural connectivity and public safety. So those are going to be two major markets for the TV white space. And there are global TV white space players. There are Canadian players, American players, and they focus on rural connectivity. But us, we do rural connectivity, but also smart construction, as well as emergency cares or the emergency services. And let me first talk about a smart village. And when there's no, optical cables, people are trying to introduce LEO or the LEO satellites. But LEO satellites, they're quite expensive, as you know. And the Starlink, I understand it's about $2. It's about 4 times more expensive than LTEs. But so for the people in developing countries, for them to use a Starlink, it's quite difficult. But they need the connection at schools. So if we could have a TV white space network, we can connect the schools and the villages, and then there we can have an e-learning service and IoT service, as well as the broadcasting service. And so with that way, now we can have low-cost connections without the LEO satellites. And here we would need a billing service, for the students. 1 gigabyte, the vouchers can be provided to students. And for residents, what they would have to pay, for the internet use. That is why we would need a billing service to be able to invoice. And in case of smart city, where we have many smart BIS in Korea, and I think there are many different types of BIS in other countries, to the bus station, we would have a TV white space. And between the station and the bus, there will be interface with LoRa, so they will be able to get the location of the buses. And with the LoRa, a GPS module can be installed on top of the buses to be used, so that we can get the location of the buses. And about the public safety, well, the cameras, these cameras can be identified, wirelessly, so they are easily detected. And also firefighters, when there's a fire, and they cannot use LTs because there's no electricity. So here with the white space, backpack type white space, they'll be able to get the connection. And about the wildfire, when there's a fire, the base stations. Because the optical cables have been burned, the base stations will not be able to work. However, with the TV white space, communication device or the network, while service will continue to be available. And also with the LEO satellites, there will be internet service available. With police and military, because of terror attacks and also the war, they need local network. And so with the TV white space, they can operate the humanoids and robots. And for smart construction, well, it's already quite well commercialized. So in the tunnels with the Wi-Fi, LoRa, and the Bluetooth network can be used to provide Wi-Fi services and provide emergency communication and identify workers and vehicles. And so we work with Hyundai and Samsung to set up this smart construction system. We have fixed TV white space, and we have edge devices that are used underground, and we also have backpack white space and the relay base station. So underground, and they need multi hops to be, so they would use, but they would need some sort of base stations underground. And for the e-learning servers, they need optical communication. And because this is wireless, the speed is not fast. And so with the TV space, we have developed the e-learning service that can be operated at a lower speed. And also the smartphones, there are a lot of IoTs, and IoTs are quite small. And so so with the TV white space, we have been able to identify the location of these small IoT devices. And same with the healthcare servers, with the healthcare server. And so this would connect to the smartwatches, so that we'll be able to check continuously the health of the elderly. And also there's something called the medicine delivery service. So we have to developed a server to provide medicine delivery service. And we also have a delivery server that can be used for a delivery of fresh foods. And we have bus BIS server that will be able to help to identify the location and the route of the buses. And the village broadcasting is a bidirectional IP speaker with two-way talk. And so I think this is the direction that we should go for Korea. So this has already been developed. And about the telemedicine server, we work with a company called Hessel. We have fixed in the backpack and trailer type white space devices. And also we have an optimization server. And the TV white space service coverage is quite important, and this optimization server will be able to display such a coverage. And for the smart construction, underground tunnel, you need to know where the workers are, and especially when there's explosion, you may have to make sure there are no people. So this is a server they will be able to identify if there are any people underground tunnel. And about the smart firefighting, but this is going to be a system that can identify where people are as well as how many people are underground. And this is a smart village app, and this is a smart farm app, and these are apps that can be streamed via YouTube. And this is a smart delivery app. This is a bus information app. So individuals will be able to know the location of the buses, so they know how much they have to wait. And so we have set up our system in 18 different cities in Jeonnam province. And in case of smart city, we have installed it in Seoul. And also we are working with another city called Gwacheon. And so we have actually connected it to thermal imaging cameras. And we also have set this system up in Gangwon province. And related to smart construction, as I said, we work with the Hyundai construction. So we have set this up in many different construction sites. So we have actually set this up in Neom City, Saudi Arabia. We have made the presentation at United Nations event, and we also have set up our system in such countries as Colombia. We have received all the necessary certification to be able to do our work outside, and we have also achieved many patents. Thank you very much.
Presentation on how TV whitespace technology is expanding global connectivity, especially in remote and underserved regions. Seeing this extensive real-world impact, I think it really showed the breadth and the scope of this TV whitespace technology. Thank you so much. All right, so throughout session 1 and session 2, we have explored the current status of radio management in Korea and also the latest trends in radio technologies. And now in session 3, we turn our focus to global spectrum management, exploring key issues and international trends. So for the first presentation, we are very much honored to have Mr. I.C. Tillman, the chairman of Working Party 1C Working Group, ITUR Study Group 1, on the topic of market trends in spectrum monitoring. Now, due to his busy schedule, he could not join us in person today, but we are very much pleased to share his insights through a pre-recorded video message. Let's take a look.
Greetings, everyone. My name is I.C. Tillman, and I'm a consultant working in the areas of spectrum monitoring, test, and management. From 1984 until just last year when I retired, I worked for Hewlett-Packard, Agilent, and then Keysight in a number of different roles related to those markets. I am a subject matter expert on Blackbird and the commercial version of that system called Surveyor 4D. I teach courses on emitter location using TDOA and have conducted geolocation trials really all over the world on all kinds of different transmitters. Finally, I chair one of the working groups in Working Party 1C under Study Group 1 of the ITU. And it is my pleasure to spend this time with you today and talk about trends in the spectrum monitoring marketplace. Next slide. This discussion is going to have two sections. The first describes challenges facing the regulatory authorities in the RF spectrum and the corresponding impact that those will have on the spectrum monitoring requirements. The second describes evolution in the spectrum monitoring equipment, including thoughts on hardware and software. Next slide. So a great place to start is reviewing how the ITU defines tasks related to spectrum monitoring in the Spectrum Monitoring Handbook, which is being revised right now and is the reason I'm doing this video and not there in person. So the primary tasks of spectrum monitoring include to detect sources of RF emissions and identify the users, to measure technical and operational characteristics of emissions, and to verify license compliance, to detect, identify, and locate sources of interference, to produce spectrum monitoring data, and to detect anomalies that affect performance of RF communication systems. We have to remember that the way spectrum is being used is changing, and this is impacting the tools and techniques we use to monitor. Next slide, please. Now let's discuss the regulatory challenges relevant to spectrum monitoring. I'm sure you've seen these three things before. Higher frequencies, wider signal bandwidths, and higher transmitter density all contribute to complexity for commercial and governmental spectrum managers. Let's think about the evolution of cellular. So FR1 has been the primary band used for mobile communications for many decades, and for good reason. It offers wide area coverage, effective building penetration, and relatively low equipment cost. However, as we all know, it's become very congested, and has no large contiguous bands available for some of the more advanced services. So the next band was FR2. This is a millimeter band that had great promise to address some of the shortcomings of FR1. But this deployment had its own challenges, resulting from lower coverage area, higher path loss, resulting in limited propagation, building and foliage penetration, and higher costs. Now, on the horizon appears to be FR3, which is a centimeter wave band, and it's currently being evaluated for application for advanced 5G and 6G. It's being referred to as the golden band, as it offers wide, contiguous bands wider than FR1 and more favorable propagation and penetration characteristics than FR2. So we'll see how that all goes. Signal bandwidths have grown as well, currently up to 100 megahertz with some 5G NR services, but this will also expand as larger segments of the spectrum become available. And we cannot forget that the density of RF transmitters in any given area has grown exponentially, especially in urban settings where the reflective environment combined with urban canyons make the spectrum even more complex to monitor and manage. Finally, the evolution of cellular technologies has made these services increasingly difficult to verify compliance and to effectively manage, just the sheer complexity alone. So the next question is, how do these challenges affect monitoring requirements? Let's go to the next slide, please. Well, they do have a direct impact on the performance and features of the monitoring network. For example, the move to higher frequencies results not only in a higher specified tuning range for monitoring receivers, but also increases the need for faster sweep speeds to cover all that spectrum with reasonable revisit time. In fact, to effectively monitor services above UHF, say 4 gigahertz, you really need a mobile or transportable monitoring solution, considering the higher path losses combined with wider modulation bandwidths. For FR2 and eventually for FR3 bands, mobile or portable monitoring equipment is an absolute necessity and will be a requirement. Next, let's talk about the instantaneous bandwidth specifications. So monitoring receivers have been moving up in this area, higher or wider and wider bandwidths. And now we're really expected to cover 100 megahertz or wider. However, some receivers offer one wideband path of 100 megahertz and a secondary path with a lower instantaneous bandwidth, usually maybe 10 or 20 megahertz. And this enables the receiver to filter out a smaller portion of the spectrum when needed. This can be very useful when you're trying to isolate a signal in a very high energy dense RF environment. Now let's talk about the high density of transmitters. So this requires the receiver front end to have a very robust IP3 and strong preselection filter scheme to accurately represent the signals in the band. It also results in a vastly increased volume of monitoring data. So to address this, more processing at the sensor front end is required, including, or let's say at the edge. So including automated energy detection, feature extraction, and database storage. TDD cellular systems have been on the rise as they make more efficient use of the spectrum, combining uplink and downlink within the same frequency band. This efficiency relies on very exact timing synchronization. Now, as a result, monitoring receivers need precise absolute time accuracy combined with a robust time domain analysis capability to detect and characterize problems. In many cases, decoding the cell ID is necessary to positively identify the source of interference. So this means more sophistication in the monitoring solution, whether in the receiver or in the software for a post-process. Let's go to the next slide. There are some additional challenges worth mentioning that are impacting equipment specifications. Let's start with discussing spectrum sharing. So in the US, the relatively new CBRS band this service shares the spectrum with US Navy radar systems. So because of the importance of the primary user, the sensing capabilities for CBRS requires 100 megahertz of instantaneous bandwidth with real-time detection and classification of the radar emissions. So that is a lot of sophistication for a service-specific sensor, but understandable given the circumstances. Cross-border interference has increased across Europe and the Middle East with the introduction of 5G NRTDD systems. The driving mechanism is tropospheric ducting of the signals, which then travel long distances with enough signal strength and time delay to violate guard band intervals or guard intervals and create interference. This is one specific issue that drives the need for enhanced time domain analysis and cell ID decode capabilities. Special events often create a more complex RF environment within a limited geographic area and over a limited time frame. Most of the challenges are during the planning phase and getting participants to register transmitter frequency plans. But monitoring is still required to make certain that participants stay in their assignments. And fortunately, there are many good examples of spectrum management and monitoring at special events in Report ITU-R SM2257. And last but not least, assaults on the GNSS bands have grown in recent years due to regional conflicts and the proliferation of inexpensive jamming devices intended to defeat tracking for commercial or industrial purposes. This form of intentional interference is difficult to detect and locate. Some effective means of localization have been demonstrated by satellite-based spectrum monitoring and crowdsourced monitoring of aircraft beacons. TDOA techniques have also been used to detect GNSS jammers in the field. Let's go to the next slide. So let's discuss how monitoring equipment has been evolving in recent years. It's been very interesting to watch how this market is developing. At the top of my observations is the impact of companies producing good quality monitoring receivers and spectrum analyzers that are extremely small, light, and low cost. This trend has been in process since about 2009, when Agilent and CRFS released small, low-cost RF sensors. Agilent's was called Minnow, and CRFS was called the RFI node. And these were capable of distributed spectrum monitoring and of making time-synchronous TDOA measurements for emitter location. And over the last several years, more TDOA-capable receivers and spectrum analyzers have come to market that can complement existing AOA monitoring solutions and stations. I expect this trend towards commodity status of monitoring receivers to continue. As these low-cost receivers become higher quality and achieve higher tuning frequencies, better filtering, and wider instantaneous bandwidths, the real differentiation in this market will be the features and capabilities of the software and the overall solution. Let's go to the next slide. So some of the trends in spectrum monitoring software include the increase in the ability to stream IQ data in wider bandwidths. Wideband IQ recording over long time periods is the equivalent, really, of a sledgehammer to construction work. The real challenge becomes finding the signal of interest or intermittent interference event buried in all those terabytes of data. This is a good application for machine learning tools like clustering or classifiers that can sort, filter, and group signal types very quickly. Circular IQ buffering has been used for real-time spectrum analysis applications in recent years, enhancing the ability to visualize very short-duration signal events. But recently, I learned of a novel application of the circular buffer. It was across an 80 megahertz bandwidth, but the buffer was 2 terabytes, and the time duration over 1 hour. So this allows temporal layering of spectrum operations, blending current, real-time observations with those of the recent or fairly distant past. This can be invaluable in terms of spectral forensics or associating emissions with other time-sensitive events. This is a development by TCI International in Fremont, California. As we look at cellular, another novel development is the emergence of SaaS, or software as a service, with cloud-based processing and storage from monitoring companies. ThinkRF, a Canadian company, has introduced this capability and offers a 3GPP scanning feature that surveys all the cellular, performs cell ID, and logs the traffic to a cloud database. So they've used this feature to solve cross-border interference issues. And of course, we're seeing more companies introduce machine learning and AI tools applied to spectrum monitoring, such as DeepSig, Keysight, TCI, and others. And a new ITU report is available that discusses this topic at length. The report was conceived in much of the work done right here in the Republic of Korea. So that concludes my brief, let's go to the last slide. So that concludes my brief talk with you today. And there are many other trends and developments to discuss, but these I picked because they could reasonably be covered in 15 minutes. Thank you again for your time and attention, and if any of you wish further discussion, please contact me directly.
All right. Thank you, Mr. Tillman, for your thoughtful insights on the global market trends in spectrum monitoring. Well, although he cannot be here in person, his valuable insights were more than enough to provide some meaningful perspectives. And we look forward to welcoming again in person in the Republic of Korea. All right. Let's move on to the next presentation. Dr. Christopher Mokone, Acting Digital Transformation Coordinator at the Ministry of Communications and Innovation, Botswana. He will present on spectrum management in Botswana today. Please welcome Dr. Mokone with a big round of applause.
만나서 반갑습니다.
It's a pleasure to meet you. My name is Christopher. And I'm from Botswana. It's a pleasure to meet you.
하지만
I can only speak a little Korean.
I'll give the presentation on the overview of Botswana spectrum regulatory framework. As introduced I am responsible for digital transformation in the Ministry of Communication and Regulation, or Communication Innovation, which includes, among its mandate, the Botswana Communication Regulatory Authority. Therefore, the experts of spectrum management are not here today, and if there are some specific questions, I will be happy to take those and share with the CEO of BOCRA. But before I start, let me acknowledge the presence of Director General of CRMS, Chong-Ho Choi, the Vice President of RAPA, Hyumbo Chung. They had hosted us as the delegates from across the world, and also the Deputy Chairman of NIPA Global Corporation, Mr. Song Hung Hong, as well as all the other CEOs of respective companies available, as well as the representative of different countries. I thank you all and happy to see you here. Thank you. My presentation, as introduced, comes from Botswana, in which Botswana is a landlocked country of 2.3 million in the heart of Southern Africa. Yes, we used to say landlocked, but nowadays we call it land connected. And the capital is Gaborone, with the country covers over 582 square kilometers. Based on those numbers, you can see that we do have quite a lot of mobility in terms of concentration levels. We have very, very few concentration levels around the country. The telecommunication growth, however, we have subscriptions to over 4.4 million and internet subscriptions of over 3 million, as shown by the rapid, which demonstrate the rapid tech adoption. The major fiber network there, we have over 12,000 kilometers of fiber cables, connecting over 223 villages and covering over 80% of the population of the country. And Botswana's efforts focus now on digital transformation and inclusive connectivity for national development. Overview of the legal framework. As I mentioned, the overall agency who is responsible for spectrum management in Botswana is the Botswana Communications and Regulatory Authority, who oversees both telecommunication and broadcasting. And the spectrum management is mandated under Section 47 of the mandate to allocate, plan, monitor, and set tariffs for radio frequencies. The key policy documents there is the National Broadband Strategy, which ensures affordable high-speed access. Pricing policy applies to administrative incentive pricing. And also now setting policy leadership is set by the Ministry of Communications and Innovation, my ministry. In terms of strategic planning around spectrum, we have national frequency allocation plans, which are aligned with the ITU as well as the SADC standards, which to ensure we have a regional harmonization of use. Since 2019, BOCRA uses global best practices like auctions, trading, and coverage obligations to optimize spectrum use. We are, as Botswana, we are active participant in the CRASA workshops and ITU working groups to strengthen regional cooperations and spectrum management. The spectrum use ensures it's seen as a strategic instrument that promotes investment and support the national broadband strategy for equitable digital access. Historical context of spectrum management in Botswana. The foundations back in 1996, there was a Telecommunication Act which established the then Botswana Telecommunications Authority, which initiated the spectrum regulation. And in 2013, the Act was improved or amended to create the new BOCRA, which converged both the communications and the ICT sector to create a Communications Regulatory Authority Act. And the digital terrestrial television migration happened in 2022, which was marked as a key milestone supported by international cooperation partners, and it adopted the ISDBT standard. And right now, Botswana reallocates 700 and 800 megahertz bands enabled enhanced mobile broadband services and spectrum efficiency. In terms of the management status, the spectrum that is there is the IMT spectrum 700, 2300 as well as 2600 megahertz to support new services. There is ongoing 5G expansion, which started in 2022 by one of the, but now it's available in all the three digital or mobile providers. And regulatory access is supported through the Universal Service Access Fund, which supports new spectrum assignments and telecommunications growth. Automating, in terms of deployment, BOCRA uses GSMF, Automated Project Management Systems, with advanced stations and technologies for spectrum enforcement and efficiency. In terms of the institutional structures and responsibilities, the Ministry of Communications and Innovation provides policy directions, oversights, ensuring regulatory framework which aligns with national priorities. The Agency of Botswana Communication Regulations is the one that handles the planning, licensing, monitoring, and enforcement to manage the spectrum efficiently. And like I said, we also have a national carrier, which is called the Botswana Fiber Network, who provides wholesale backbone connectivity, offering open access to national and international networks. Within the BOCRA department, we have the Department of Radio Spectrum Planning, Licensing, Cybersecurity Incident Response Team, which collaborates to ensure quality and compliance. The processes that are being deployed are a spectrum management structure, which uses a structured approach, including planning, assignment, pricing, and monitoring of the spectrum. And we also have the National Frequency Allocation Plan, which is regularly updated to align with international and regional standards, hence the need for the country to continue engaging with on platforms like this. The assignment and pricing method, spectrum assignment uses auctions currently and beauty contests with prices including market fees and incentive pricings. And there's all, like I said, there's also have the Universal Access Fund, which is used to finance where the issues are not feasible. Monitoring compliance through SMS with database integration ensures violation detection and improve service quality. The future directions is that BOCRA, we are looking at completing the awards of 700 megahertz as well to enhance network capacity, and the full rollout of SMS nationwide is also continuing to also improve spectrum efficiency. And we are now looking in terms of exploring mid-band 6 gigahertz as well as the millimeter wave frequencies for next generation advanced services, and also incorporating AI-assisted management, private 5G networks, and NGSO satellite coordinations. Just quickly, in terms of the organogram of organizations responsible for this in Botswana, at the top there, as I indicated, is the Ministry of Communications and Innovation, responsible for policy. The regulator is the Botswana Communications Authority, and they have three main departments, being Department of Spectrum Planning and Engineering, Licensing and Monitoring and Compliance. And in terms of fiber, we have the Botswana Fiber Network, and the main operators are Orange, Mascom, and BTCL. Regional and international cooperations comparisons there. As you can see, in Botswana, the 700 megahertz is available, same as around our SADC countries as well as in Korea. The 3.5 gigahertz is still being planned in Botswana, but partially implemented in our neighboring countries and fully deployed in Korea. 6G gigahertz in Botswana under review, as well as in SADC countries, whereas there's already a roadmap developed for Korea. 5G, 6G roadmap, 5G launched already in Botswana and 6G not yet determined, whereas in Southern African development countries, 4G is spread and 5G, they're still working on it in some of the countries. Similarly, in Korea, you can see that we have a nationwide adoption of 5G and 6G scheduled for 2028, maybe earlier, I don't know. And in terms of the readiness for the next generation spectrum management, we need to work on ensuring that our legal institution and framework are properly established. We need to look in terms of spectrum modernization, as well as ensuring that the 5G rollout status that was commercially launched is adequate. AI-driven spectrum management is needed, and we are also looking into ensuring we have regional alignment. I think those are the main ones that I wanted to touch, and I see, as was indicated at the time, is very, very short. But any other technical questions, I'll be happy to take back to the Botswana Communication Regulatory Authority. Kamsahamnida.
Well, thank you, Dr. Makone, for sharing Botswana's comprehensive rundown of the regulatory framework and also the status, while also sharing Botswana's unique spectrum management journey and, of course, its future roadmap. Thank you. Right, so next up, we have our final presentation for the day. For the final presentation, we are very much pleased to be joined by Dr. M.D. Sohail Rana, the Director of Bangladesh Telecommunications Regulatory Commission. He will present on the topic of management of IMT spectrum in Bangladesh. Ladies and gentlemen, let's give him a big round of applause.
Honorable Director General, CRMS, Mr. Jun Ho Choi, Vice President RAPA, Hyung Bo Cheung, distinguished delegates, ladies and gentlemen, good afternoon. My name is Dr. Sohail Rana. I am acting as a Director of Spectrum Management in Bangladesh Telecommunication Regulatory Commission. I would like to explain our spectrum management policy and process pricing in Bangladesh. In the beginning of my presentation, I would like to explain what is spectrum management. In Bangladesh, we follow this kind of structure for managing spectrum. It is authorization, planning and engineering, and control. So authorization, in terms of authorization, we follow auction, administrative process, beauty contest, secondary trading. But secondary trading is not allowed in Bangladesh according to the law. And all these cases, this is a very important thing is spectrum price, which we determined by different spectrum pricing methodologies. We plan and planning the band following I2 radio regulation, and we control the spectrum based on command and control approach, spectrum sharing and unlicensed. But for IMT spectrum, we follow command and control approach since spectrum sharing is not allowed still. But unlicensed, we assign spectrum only for ISM band and some other sharing bands as sharing. So what is the efficient spectrum management policy? We can achieve efficient spectrum management policy in two broad heads. One is technical efficiency, another one is allocative efficiency. Technical efficiency can be achieved by minimum input and maximum output, which depend on spectral efficiency. And allocative efficiency, it depends on shadow price derived from input mix such as spectrum and BTS. And beside allocative efficiency, allocative inefficiency may be happened if spectrum price is derived from wrong input mix, technical inefficiency may be happened for the technology-based license if spectrum is assigned based on technology. If technology neutrality is not allowed, and market price divergence from shadow price. If the shadow price is much higher than the market expectation, then inefficiency may be happened. So this slide explains the spectrum assignment for mobile communications in Bangladesh. We have 4 operators, Grameenphone, Robi, and Banglalink. The major operators, Grameenphone, they have almost 87 million subscribers. This is the connection, not subscriber, it is subscriptions. And their assignment is 127 megahertz. Robi, the second largest operator, they are acquiring 57 million subscribers, and their assignment is 124 megahertz. Third largest operator, Banglalink, their subscription is 38 million, and they have assigned 80 megahertz spectrum. And government-owned, state-owned Teletalk, their assignment is very high, but their market share is very low. They have assigned 55 megahertz spectrum. And currently, we have assignment from 900, 1800, 2100 to 2.3 gigahertz and 2.6 gigahertz band. And different operators are assigned spectrum like this. So this is the pricing era in Bangladesh. We have 3 distinct eras. In 1993 to 2004, the spectrum is assigned at free of cost. In that time, government didn't charge for assigning any spectrum. But first time, administrative process is started in 2005. And in 2005, price of spectrum per megahertz was 5.75 million USD per megahertz. In that time, we have assigned 15 megahertz spectrum from 1800 megahertz band to Airtel, Bangladesh Limited. Then in 2008, it was the price is 12.3 million USD. Then in 2011, it is 20 million USD. In 2013, when we assigned spectrum through auction, and auction is started from 2013 for assigning 3G spectrum from 2100 megahertz band, and the price was 21 million USD. And in 2018, the price is increased to 31 million US dollar for 1800 megahertz band and 27 million US dollar for 2100 megahertz band. But this auction was unsuccessful, since only 30% spectrum has been sold. But in 2021, the price didn't increase, but we have given flexibility to determine their duration of assignment. Our price is for 15 years, but operators were free to decide the duration. In that time, operators choose 5 years for the assignment. And we put to the auction 27.4 megahertz spectrum, and 100% spectrum has been sold. And 1800 megahertz band was sold in 31 million US dollar, and the offered spectrum was 7.4 megahertz. And from 82 to 2100 megahertz band, we offered 20 megahertz, and 100% spectrum is sold. 15 megahertz has been sold in 29 million USD. But for the last block, 5 megahertz, it has been shown fierce competition between 2 operators, Grameenphone and Robi, and price is increased to 46.75 million US dollar. And then 2022, we follow the same process like 2021. Operators are free to decide their duration, and they acquired spectrum for 10 years. And the price was 6.5 million US dollar for 2.6 gigahertz and 2.3 gigahertz band. Price decreased because this band is a TDD, and it's very high range and required more investment. This is the trend of pricing of spectrum in Bangladesh. The price is increased over the years, but I think this kind of trend is opposite to the trend of spectrum price in the globe. If we compare the spectrum price with our neighboring country, India, we can see that their price decreased over the years. In 2021 auction in India, their auction was very unsuccessful. Only 37% spectrum has been sold. That's why in 2022, they decreased spectrum price significantly. Almost 50% they decreased. And the auction was remarkably successful. More than 90% spectrum has been sold. Then if we compare the price of 1800 megahertz band with the, India, Bangladesh and Pakistan, we can see that price of spectrum in Bangladesh, it is higher than India and Pakistan currently. Initially, in 2016 and 2021, price of India is higher than Bangladesh, but in 2022, price of spectrum in Bangladesh is less than India. And Pakistani spectrum price is also lower than Bangladesh. Similarly, in 2100 megahertz band, we see the same trend. Now, price of India is lower than Bangladesh and Pakistan also, since Indian average revenue per user per month and GDP growth is much more higher than Bangladesh and Pakistan. If we see the price of 2.6 gigahertz band in some developing and developed countries, we can see that price of Bangladesh is more than Vietnam and India. In Bangladesh, auction has been held in March 2022. After 6 months, Indian auction has been held, and they followed the price of Bangladesh, and their price was a bit lower than Bangladesh. But the price in some advanced countries like Germany, Thailand, Italy, Australia, South Korea, Singapore, this is much higher than our region. In South Korean, I have got this information from 2012 spectrum auction from 2.6 gigahertz band, and Korea assigned the spectrum in FDD technology, not the TDD. And other countries' price is TDD. This is the average revenue of different countries. In Bangladesh, our average revenue per user per month is very major, $1.13, which is lower than other countries. Maximum ARPU has been shown in USA, then some other countries has been shown. And the ARPU of Vietnam and India also higher than Bangladesh, but ARPU is lower, but price in Bangladesh is higher. So this is the process of spectrum pricing that we follow. First of all, I would like to explain about engineering valuation approach, which we follow to determine the spectrum. This is the trade-off between spectrum and BTS. And the producer surplus gathered from assigning additional spectrum. If additional spectrum is assigned, so how much cost savings can be achieved from the additional spectrum? From this theory, we can derive price of spectrum, and this process is validated by ITU report in 2012. Then we follow production function model. This is Cobb-Douglas production function. And here two input parameter like quantity of spectrum and number of base stations as the input, and output is total traffic or subscriptions. And we can transmit that nonlinear equation of Cobb-Douglas model into linear by taking logarithm, and putting the data can make a panel, and we can solve this model by generalized estimation equation, and we get the price of spectrum. And we follow another model. This is the revenue surplus model. That means the cost savings, cash flow, revenue less cost. And we determine the net present value, and we can derive the price of spectrum from that kind of equations. Then we can see the spectrum assignment versus revenue. In Bangladesh, spectrum assignment is increased, but over the year revenue didn't increase like assignment of spectrum. In 2016, 92 megahertz. In that time, our total revenue was 19,000 crore BDT. It is in BDT. It is increased to 31,000 crore, but spectrum assignment has been increased to 236 in 2023. We can see that spectrum assignment has been increased 157%, but revenue has been increased in 61%, but price is increasing. So this is the critical situation in Bangladesh. Then if we make a relationship between revenue and spectrum assignment, since revenue of mobile operators depends on independent variables like competition, which is measured in terms of liberalized market and Harfindal-Harshman index, GDP per capita, subscriptions, tariff, rival service operators' revenue, like fixed service revenue, and assignment of spectrum. If we make a data set and make the linear regression, ordinary least square regression, we can get this kind of relationship. When HHI, Harfindal-Harshman index, as a proxy for market competition, we can see that spectrum is negatively correlated with revenue. That means our spectrum assignment has been increased, but revenue increased, but not like the proportional of spectrum assignment. That's why we get the negative correlation between spectrum, assignment of spectrum, and the revenue. So this is our 5G rollout plan. We have assigned 5G spectrum in 2022 from 2.3 and 2.6 gigahertz. And our 5G rollout policy formulation is ongoing. And our auction process of 700 megahertz band is ongoing, and hopefully within December this year, we will auction 700 megahertz band and 3.5 gigahertz band to be released in 2027. We have formulated our spectrum assignment roadmap, and spectrum assignment roadmap is formulated based on ITU report M2370, where the process of estimating the traffic is described. We estimated the traffic from S-curve methods. Then we forecast the spectrum requirement and framing the roadmap of spectrum assignment. This is the estimation of S-curve. We estimate bus, logistic, and GOMPART's 3 distinct diffusion models or S-curve models. And we have shown that GOMPART's model is the best suiting model for Bangladesh to estimate the traffic. And our potential subscriptions is like 115% of our total population. And if we apply this traffic data, subscription growth, and this is the traffic per capita in Bangladesh. Traffic per capita is much lower than global and our neighboring countries. Our current per capita traffic is almost 8 GB per month per user, and it will be increased to 27 GB. This traffic is per connection, not that per user. Based on this traffic data, we estimate the spectrum requirement up to 2035. Spectrum requirement in 2023 is almost 600 megahertz, and it will be increased to 1600 megahertz, which is close to the forecasting of ITU, while ITU estimated that almost 2000 megahertz spectrum is required up to within 2030 in each country. So this is our spectrum roadmap. In 2025, we will assign 700 megahertz band. In 2026, we have renewal of several bands from 900, 1800, and 2100 megahertz band. Almost 79 megahertz spectrum to be renewed in next year. Then in 2027, we will assign 460 megahertz spectrum from 3.5 gigahertz. And in 2028, we have another renewal from 2100 megahertz band. And 2029, network 2G network will be shut down. Since at present our smartphone penetration is not more than 50%, and more than 50% people is using feature phone. In 2031, we will assign 600 megahertz band. In 2032, we will assign 1400 megahertz band. It is our plan. And 2033, we have some spectrum band renewals. And 2034, also some renewal. And we will assign 700 megahertz band from 6 gigahertz band. This band is from 6425 to 7125. This is the most favorable band for as a mid band for 5G. We will assign this spectrum from in 2035. This is the end of my presentation. If you have any question, please let me ask.
Well, thank you, Dr. Rana, for shedding light on Bangladesh's IMT spectrum management with a special focus on the spectrum pricing and, of course, the roadmap of future spectrum assignment. Now, ladies and gentlemen, let's take a short break to enjoy some refreshments before the final Q&A session. This time, we'll reconvene at 4:40 p.m., so it's going to be roughly 20 minutes. We'll be back shortly. YMX예요. 아, Ladies and gentlemen, the final Q&A session will begin shortly. For those in the lobby and in the lounge area, please enter the event hall and take your seats. Thank you for your cooperation. Ladies and gentlemen, let's begin our final Q&A session. So we have prepared a very special Q&A session with participants that focus on today's session topics. You can see the change of seating and table plans. So for this special Q&A session, I would like to invite Professor Il-Kyu Lee, the Professor of Electrical, Electronic and Control Engineering Division at Gwangju National University to serve as the moderator for this Q&A session. Now, Professor Lee has worked extensively in areas related to RF development of WCDMA and radio monitoring systems for nearly 10 years at ITRI. Now, joining him on the panel are Mr. Hyun-Soo Kim, Deputy Director of CRMS, Mr. Jong-Seung Wang, Assistant Director of RRA, and Mr. Kwang-hee Kim, Research Officer at SRMC, Mr. Kang-hee Kim, Principal Researcher at ETRI, and Mr. Yu Ho-sang, CEO of InnoNet, and Dr. Christopher Makone, Acting Digital Transformation Coordinator at the Ministry of Communications and Innovation, Botswana, and lastly, Ms. Dr. M.D. Sohel Rana, Director at BTRC. Ladies and gentlemen, please give a warm round of applause for our distinguished moderator and panelists.
Thank you very much, Ms. Lee, for your kind introduction. Okay, I'm so pleased to take a position as a moderator about a discussion on the topics that were presented during our forum. But I would like to make some note that unfortunately, one of our presenters, who is Tae-wook Hwang, right now he is out of this meeting. He has some special business, urgent business. So I would like to ask your understanding and generosity. And also Dr. Mirshoel Rana and Dr. Christopher Makone. Okay, thank you very much. And also Dr. Mr. I.C. Tillman. He gave some video clip, so he couldn't participate in as a panelist. So now it is time for us to opening the floor to have some discussions. So if there is somebody who makes some comments or some questions, please speak slowly and speak clearly for our convenience. Okay. Now, okay, we can start with the discussion now. So anybody who has any questions, and then raise your hand, and then I will give the chance to speak. First, Mr. Walshade. Okay, you can go ahead. Any assistance to give some mic to Mr. Walshade? Okay, thank you. Okay, Mr. Walshade, you can go ahead with your.
Thank you very. Yes, thank you very much once again for giving all of us this chance just to listen to all these presentations and the distinguished presenters, and having the chance just to discuss with them and have some insights, more insights other than they give us during their presentation. I may have some curious about some topics, but I want to take all the time for myself. So I could start with only one question for the distinguished colleague that gave us some insights about the merging the AI with the spectrum management. If he could give some insights about the practical or the practice of the South Korea about using the AI in the spectrum management framework, because I think we took some or a lot of the theory of merging the AI and the spectrum management, but it could give us some experience of South Korea on this topic specifically. Thank you.
Thank you very much, Mr. Walshade. Maybe you ask the question to the Mr. Kim Kang-hee, I think. So, or Mr. Kim Kang-hee or Mr. Kim in CRMS. Okay, yeah, so you can explain what he is concerning about the practical AI deployment in our country.
Thank you very much. From SRMC. So I think your question is how we utilize AI for spectrum management. And so, as the presentation, as I said in my presentation, we plan to build a platform on which we can use AI to do spectrum management. So as of now, we do not use AI for spectrum management. But we would like to use AI and big data so that we can do more effective and efficient spectrum management. So we are going to build a system. And so we are in the review stage. And then we are going to set up a plan. And we actually set the scope for the budget. And so I believe that we're going to need about 12 billion won in order to be able to build this platform or system to use AI for the spectrum management. And we are going to begin building that system next year. And that is going to take us about 5 years to build.
Director Hyun-soo Kim, maybe Mr. Walshade, is it understandable to you? Well, now Korea does not is planning for the AI spectrum development, AI spectrum management development. So, thank you very much. And KA. And the Director Kim, so please.
네, 안녕하십니까.
Good afternoon. Actually, I like to add on what he just said. So actually, we are not doing from scratch. So several years back, we have spectrum management platform to be reviewed. So we are looking at the areas of AI application. So demonstrations started several years back. Based on that, ITR report was adopted. And to be specific with you, so spectrum monitoring data should be accumulated by us. And when we carry out analysis for that, there is a radio waves. So spectrum waves, for example, the waves will be generated. Then through the learning or training on AI is able to identify anomalies or not. So actually they can learn the licensed frequency spectrum. So there might be some anomaly patterns detected by AI. So then AI at that time identifies this as illegal or unlicensed spectrum waves. So that's why AI is able to be swift in identifying the source of interferences. So as of now, humans are now manually analyzing the data extracted in front of the desks. So they need to identify the source of interferences by human labors. But actually this can be swift toward AI for quicker identification of sources of interferences. So a quicker identification of sources of identification can be carried out by AI. So AI will replace humans' labors here. This will be the future landscape that we are envisioning.
Division in CRMS. Okay, she explained a little bit more detail with respect to the practical development of spectrum management system, which was based on AI technology. Thank you very much, Ms. Director of Radio Planning Division. Thank you very much. Okay, so let me ask you kindly, whenever you have a chance to give some intervention or questions, please announce your name and your affiliation from some organization or some country. Okay, and then let's move on to have a discussion continuously. Are there anybody who has any questions? You can choose some presenter. Okay, you can ask some special presenter, whatever you want to ask with your content. Okay, your name and affiliation or country.
Thank you very much. My name is George William Kasangaki from Uganda, working with the Uganda Communications Commission and in charge of spectrum management. My question goes to Mr. Kim regarding satellite communications. All right, that was a wonderful presentation given regarding satellite communications and the steps that Korea has undertaken in the monitoring of satellite communication services. I was fascinated when you highlighted Article 22, 181E, regarding the EPFD. Now, during WRC 23, that was a very hot topic, the revision of Article 22, particularly the EPFD. And then at that conference, there was a resolution that studies be conducted to see whether the provisions under Article 22 continue to suffice for the protection of GSOs and NGSOs. Now, preliminary studies are torn GSO and NGSOs. Korea has established facilities to monitor interference due to satellite communications. I would like to pick your mind on what you anticipate, whether it is necessary to touch Article 22 or not, because since 2000, GSOs have coexisted with NGSOs, though we understand and recognize that the proliferation of NGSOs is increasing. What is Korea's view or position regarding the ongoing studies? It could be quite a forehead, but I would like to pick your insight because I'm much interested in satellite communications, LEOs, that is NGSOs and GSOs. Thank you very much.
Okay, thank you very much, Mr. Joji from Uganda. Okay, Mr. Kim, can you answer to his question, or what is your response to his question?
네, 질문 감사합니다.
Thank you very much for the question. We have when we thought about how we're going to do the LEO satellite monitoring system, and the most important thing at that time was how we're going to handle EPFD. And we had discussed with many experts here in Korea. And according to the recommendation I2R, whether we'll be able to accumulate this was an issue. And so how to handle EPFD, that was an issue and something that we paid a lot of attention to. Well, EPFD, and so we are going to do, we plan to implement according to the recommendation from I2R. And so, and this is not an issue that can be handled by Korean companies, and therefore we're talking to global companies, and how we can look at this, how we can visualize, EPFD. So we're discussing about this, and the country with the technology, and so we want to work with a global company that has the know-how and technology. So we're working very closely with this company, and we have partially verified the solution of this company with technology-wise, And so we're going to buy that solution, and of course we're going to make some changes or corrections. So this is going to be the most difficult project for us next year. And that was a wonderful question. Thank you very much.
Okay, thank you very much, Mr. Kim. Well, okay, yes, so you want to ask us more questions or just Mr. Okay. As far as I understand, the non-GSO increase is rapidly recently these days. So the protection of GSO from non-GSO is a very important issue and a hot issue in the ITOR. That's why you mentioned that radio regulation Article 22 is supposed to be maybe updated or not. That's why there's some kind of conflict between many countries. So you wanted to know what's going on in Korea, but he answered that now he's going to develop some power limit of EPFD with the cooperation of some companies which developed this monitoring system. I think you understand with this his answer. Are you fine with his answer? Okay. Okay. Thank you very much. Appreciate it. Okay. I will move to another. I will give the floor to the participants in this room. Anybody have any questions? Mr. Walsh, thank you very much for your raising your hand.
Thank you, Dr. Lee. Maybe my next question, yes, to Dr. Sohail, about the national roadmap for the spectrum. I think he showed us that he has some planning for the 6 gigahertz band. So I want to learn about the views of Bangladesh about this piece of spectrum and how this could be regulated in his country while it is recently studied in the and not yet decided by the WRC. So if you can give us some insight on this part. Thank you.
Thank you, Mr. Wells Said. Actually, you know that 6 gigahertz band has two portions, right? Lower portion is 5925 to 6425 megahertz and 6425 to 7125 megahertz. So lower portion we have already declared for shared IMT. It will be used for Wi-Fi or IMT, something like that. And this is like on kind of unlicensed and shared. But for upper portion, we have a proposal to WRC 23 to write our name in the footnote of radio regulation. But in that time, we have many proposals from this band is proposed for IMT from region on, and it is approved. But for region 3, China has given a proposal to CPM2 of WRC 23. And then we have a joint proposal and individual proposal also. For region 3, you know that a footnote has been created, and 3 countries only could write their name: Maldives, Laos, and Cambodia, maybe. Cambodia, yeah. And in China, Bangladesh, and some other countries could not because of objection from India. This band, you know that this band is co-primary for both mobile and FSS, right? So we can use this band within our country, within the geographical boundary of Bangladesh. But we tried to harmonize this band as like region on, in region 3 also. But this in this WRC 2027, India is already agreed and they have given proposal at APG 2 that has been held in August 2025 in Bangkok, and they have no objection now. Bangladesh also support Indian position since we already agreed this band for IMT, and hopefully in 2027 WRC we can write our name in the footnote. And many countries like China, India, Bangladesh, Thailand, maybe Sri Lanka, they would like to join in that footnote. So we have a provision in the radio regulation and our national frequency allocation plan that we can use this band in our territory without identification of IMT. But it will be good for us if we can write our name in the footnote. But this problem will be solved maybe in WRC 2027. We are hopeful. And this 700 megahertz, entire 700 megahertz from 6425 to 7125. You know that 7025 to 7125 it is already identified for IMT globally. So other 600 megahertz it will be solved. So we will use this band as a mid band for 5G, and it is our plan to assign this band after 2000 or before 2035. This is our position.
Okay, thank you very much, Dr. Mir Joel, for answer for the questions from Mr. Walshade. Well, as he mentioned, during WRC 23, India had objection to objection to identify the upper 6 gigahertz band for IMT system. Maybe because of their national issues, especially satellite communication, something like that. But Bangladesh and China is tried to put note in upper 6 gigahertz band as the IMT designation.
Yeah.
But as you said, in coming WRC 27, there is no strong objection.
India is already
agreed already.
Yeah,
Okay.
India is already agreed, and they have given proposal in preparation meeting of WRC 27 that has been held in August, this year August in Bangkok. Okay. And they have given written proposal that they are agreed to use this, identify this spectrum for IMT.
Okay. Anyway, thank you very much for your explanation about your position in Bangladesh position in upper 6 gigahertz band for the IMT designation. Okay, appreciate it. Okay, I will keep on moving on for further chance to have a discussion. Is there anybody in the floor to request for the intervention? Okay, I cannot see. Thank you very much. Again, I will give you the follow-up to you.
Thank you very much. George again. Spectrum management and its development across the world relies on best practices and sharing. Now, I found it quite interesting that the Korean system has it separated in such a way that the one entity that is responsible for assignment is different. Then CRMS goes for the monitoring aspect. Then there is another that does inspection of radio communication systems and installations. Whereas in most of developing countries, all these functions are housed under one entity, that is the regulator. So I would like to pick from Korea, and I don't know to whom to direct this, but one who comes to my attention is Director Kim from CRMS. What are the efficiencies that Korea has registered in that kind of arrangement, and what were the challenges, or what, if any, is existing that maybe some of the developing countries can borrow to see that we further improve our spectrum management processes? Thank you very much.
Thank you very much, Dr. George Williams, for your another meaningful question. Well, is there any presenter to give answer to his question? Okay, his question. Okay, you go ahead, Deputy Director, Mr. Kim.
So actually, spectrum management of Korea, spectrum allocation, assignment, and management inspections on radio stations. So you throw out questions with regards to three issues. In Korea, there is a structured spectrum management, so policy designing and implementation bodies and relevant organizations are joining their hands together. There are separated approaches here. So actually, when there is a spectrum management policies to be designed, and international bureau is responsible to ITU, and this all belonging to the responsibilities of Ministry of Science and ICT. So ITU allocates the spectrum resources to be assigned, then these efforts are done by Minister of Science and ICT, and there are specific usages to be allocated. And the Minister of Science and ICT oversees those process, and policy implementation-wise, in a detailed manner, there are enforcement organizations. So Central Radio Management Services, case in point. So licensing to the radio stations are our responsibility, CRMS. So there are spectrum assigned to its usage. Then there are multiple types of radio stations. So per usage, our service is responsible for licensing radio stations, and we're also responsible for inspecting the radio stations to see whether they are compliant with their license. But there are many radio stations, so we have some certain limitations in human resources. So that's why, so actually CRMS is belonging to the Korean government. So military and broadcasting stations and national infrastructure are our areas. So mobile telecommunication, mobile service carriers, radio stations, the inspections are done by the Telecommunication Promotion Association. So actually, I do believe this is a systematic approach. This is the current status of Korea's spectrum management.
Mr. Kim, his key point, the key point raised by Mr. George William is what is advantage or what is efficiency? I mean, Mr. George Williams said that in Africa countries or in Arab countries, usually one entity is taking care of the spectrum assignment and also spectrum monitoring. But in particular, here in Korea, we separated two organizations. So he wanted to know what kind of advantage or efficiency director of
네, 다시 발언을
director.
So it's me again. So actually, I am Kim Kyung-ah, Director of Spectrum Management Planning from CRMS. So Deputy Director has elaborated on the separate roles in detailed manner, but actually there is no winners here. So each system has its own benefits. Especially there is a nation-specific communications or spectrum management system. So in case of Korea, the telecommunication mobile MNOs are private sector, so there are many constraints here. So that's why we have separate roles, inviting the public and the private. Some countries MNO are publicly owned. So we need to consider the characteristics or nature of each country. But what's important here is that when we take a separated approach, then we need to reach a consensus on standards. So KCRA is responsible for inspection on radio stations. So we need to reach on consensus of standards and procedures that we also, both of us, need to follow through on. So rules setting with specific plans are areas of the private, and private sector can take their roles as well.
Director of Radio Planning Division in the CRMS, Ms. Kim. Well, yeah, it is not easy to make just a correct answer for your questions, depending on the situations in different countries. But as she said, so in order to make some systematic management of the affairs, and also the affairs are, the volume of affairs are growing too much, and then so divided organization could concentrate on that specific affairs, and with the cooperation from other organizations, like in a private organizations, something like that. Okay, thank you very much, Ms. Kim again. Well, I will give another chance to have a intervention. Okay, would you? Okay, you can take the floor. Please, your name and your country.
Okay, thank you very much for giving me the floor. My name is Christian Kwesikwam Edu from Ghana. I work with the Ministry of Communication, Digital Technology and Innovations. My question goes to CRMS in South Korea. In fact, let me say South Korea as a whole. I wanted to find out from the presentations that they gave the current status of spectrum management in Republic of Korea. I wanted to find out how they balance spectrum management with the public and then commercial users. When I say public and commercial, I'm saying that with the commercial users, South Korea generates a lot of revenue from mobile operators or mobile users. But with the commercial, which is the police and the military, they have to reserve a lot of spectrum for them. So how do they balance this? Is it different spectrums for different people, or how is it done? How do they go about it? Thank you.
Thank you very much. You're Richard, Mr. Richard. Mr. Christian Crazy Quarom. Okay, thank you very much for your question. Maybe this forum is hosted by CRMS. That's why there are many questions with the CRMS. Mr. Kim, are you ready to answer for his question?
네. So actually our spectrum policies are all governed by Ministry of Science and ICT. So when our spectrums are assigned from ITU, there is a public and a commercial. There are different usage of spectrum. So the Ministry of Science and ICT has separated different uses. And per each usage, there are allocated spectrum and bandwidth. So actually, spectrum allocation done first of all. But the radio stations, when it comes to military, so we do not introduce licensing of introduction of radio station, but we approve their usage of radio stations. So for the military purpose, so there is specific usage of the specific bandwidth. So the bandwidth is approved by the ministry, and within the bandwidth, the military is free to utilize the radio stations within that bandwidth. And for the commercial purpose, those kind of frequent spectrum, we do have a licensing for approval of installation. So operators need to apply for application to get approval from us. So if they are technically viable, then we give them green light. And also there is a conformity assessment scheme which looks at the capabilities of prevention of interferences of equipment. So there is a reporting system as well. So except the military sector, there are licensing scheme. And for the military purpose, actually we give them approved spectrum bandwidth for them to freely utilize the bandwidth. I hope this satisfies your curiosity.
For your answer to the Mr. Christian, okay, it is okay with you for the answer? Okay, thank you very much. Okay, I would like to give another follower to. Okay, I can see raising hand from the floor.
I'm Tariq from Egypt, Arab Organization of Industrialization. My question here is...
excuse me. I'm sorry. What is your name?
Tariq.
Okay. Tariq. Thank you.
Okay. We're talking here about the global spectrum management. And my question is, in general, how will global spectrum management evolve to accommodate the increasing demand of wireless communication technologies?
So maybe your question should go to some presenters. Why don't you? Okay.
It's one of our challenges. So we have a demand in this technology. How we can face it? It's very hard.
Maybe Mr. Walshade, you better answer for his question. Okay. Globally, how to manage this spectrum? Like that. Would you please say something about his question? Yes, go ahead, please.
Thank you, Mr. Tariq, about this. Actually, some question like this, I was expecting you just to approach me and ask, but okay, if it is publicly, no problem, just to answer you, no problem at all. Yes, actually, the global demand for wireless telecommunication is handled by collaborative work through the ITU. We have a World Telecommunication Organization under the umbrella of the United Nations. They are harmonizing the views and positions of and requirements and needs of all countries all over the world, and generate some sort of collective work in many different scopes and telecommunication services, and try to collect all these needs and make studies, then collect their type of studies in some sort of gatherings like world conferences. They gather all countries in some place, could be bigger than this room, and review the results of these studies and make decisions to be reflected in some sort of world or international type of radio regulations. Yes, and try to, through this kind of radio regulations, just to satisfy the whole needs of the world together, because every country has its own needs and its own requirements. So if these countries tried to satisfy their individual needs,
big conflict. So we are trying just to harmonize all the needs and requirements in bigger room than this, may take 1,000 people inside it, and try to find a solution for every part of the problems or requirements. That's it. Thank you very much.
Thank you very much, Mr. Tarek's question is a generic question. How to make global spectrum management in reality? It was too much generic, so maybe, okay, Mr. Walshade, he is expert on I2R study activities. That's why he emphasized that the spirit of I2R as a cooperation and harmonization. Well, this is generic question and generic answer. Okay, thank you very much. Okay. Okay, I will give another chance to follow up for raising questions or comment. Okay, again, just a minute, please. I will, wait for 1 second to try to figure out if there is another person who have any questions. And then, without any raising hand, I will give you the follow-up again. Okay? Okay, go ahead, please. Now, I cannot see the raising hand from the floor. That is why I will give another chance to you.
Thank you very much. And this will be my last question for this evening.
Probably you can ask a question because we have 10 minutes left.
And it goes to the present of TV white spaces. TV white spaces have provided technically enormous opportunities to provide communication to rural communities and industrial setups. Now, the trend we know is that IMT, broadband technologies, in terms of their spectrum demands, are coming down the spectrum block. I know Region 1 and Region 3 are using the TV white spaces in the band 470 to 694. There is a potential of continued demand for IMT probably in 2031 for more spectrum coming down into the TV band. Now, given that South Korea has made strides and developments in utilizing TV white spaces, how prepared is Korea and perhaps the APT region when it comes to IMT coming down? How is the TV white space going to be managed, the development and all the innovation that has come around it? Thank you very much.
Thank you very much. Maybe you are interested in IMT designation also. Okay, maybe. All right. Mr. The TV white space, maybe CEO of Mr. Okay. Yeah. Okay.
Well, I think it's going to be the government that is going to be announcing about the IMT designation. But I'm going to talk from a company's point of view. Well, I think that I think it's different for advanced for some countries and other countries, where Korea has optical cable to the last mile, and so the white space will be needed for underground and for disaster areas to save lives. But I believe that in developing countries it would be quite different. With the LEO satellites, well, it can be used to provide services to the rural community. But LEO satellites are quite expensive, so you can set on the private network with the TV white space to provide more affordable at affordable prices, but you would need many different servers. And also a TV white space. Well, the internet has to be used by everyone, and so it has to be fixed fees. And the mobile router, it's about route is it's not that expensive, but if you're going to use it remotely, with the camera, it's going to be very expensive. And so in South Africa, I have learned that they will have an optical cable, and the last mile is where it's expensive. So that is why they have merged, optical cables with the TV white space. And so the last mile is established or formed like that. And so optical cable and TV white space would be merged and at a fixed fee of like 20,000 won or the 30,000 won. And I think that's the way in order to increase the penetration of internet.
To Mr. Yu for your answer to his question, but his key point is to know what is planning in Republic of Korea about how to use the TV wideband. Maybe some other countries are trying to use TV wideband as a IMT utilization. So he wanted to know about this this policy in Korea. Okay, government official. Maybe Mr. Kim, you can answer for his question a little bit more detail.
TV white space, where in case of Korea, this is between 470 and 690 hertz. And so Korean TV channels, it's about 6 megahertz. And there are 38, so there could be potentially 38 channels. And about the IMT 2030 spectrum or the frequency, it's different from that IMT spectrum. And so for Korea, the TV white space is used between the bands of 470 and 698.
The frequency assignment it should be decided by government policy. So even though there is some request from the commercial area, like providers to use this TV white space band, but still in Korea, the government will handle with this frequency band. So I think, but as you said, many countries are interested in moving the frequency band, using the frequency band, this TV white space as a IMT utilization. Okay, that is true. Okay, are you okay with his answer? Okay, thank you very much. We have 4 minutes to go. So, okay, presenter. Okay, you raise your hand and you can say something that you want.
Yes, I just want to make a follow-up to my colleague there. Earlier on, he asked a question about why in Korea we have specialized agencies handling different parts of spectrums. But in developing countries, what could be the advantage? So I just wanted to say, because of the difference in capacity and complexity of different countries, in most maybe developing countries, what we could aim for could be to ensure that we create maybe specialized units inside a single organization. In the context of Botswana, we have BOKRA, which within that one, we could then create specific units which are going to behave and make sure that we cover all the necessary assignments like the spectrum planning unit, the monitoring and technical unit, but this can also be able to work in such a way that they give us the necessary focus, accountability, and technical specialization that we see happening in big Korean agencies. And we could also ensure that there's adequate inter-agency collaboration between whereby we'll have the ministry setting the policies, and then the research institutes could be able to provide research as well as maybe the law enforcement officers that who could then come in and ensure there's necessary compliance on the legal use of spectrum. So this is just, I just wanted to give that perspective
of that if we are unable to roll out extensive agencies like Korea, we can still do that within the small resources that we have. Thank you very much.
Thank you very much, Mr. Christopher. You just gave some, complimentary remark, or just, just your general opinion, or what is your point exactly?
It's just a complimentary remark, just to ensure that we don't, because we answered only the context of developed countries, but we did not say anything about what we could do as developing countries.
Okay.
Thank you very much.
Thank you very much, Mr. Christopher. Maybe you can make a time to talk about it with the government official after our discussion. Maybe it is going to be effective or useful to understand or to get some idea further, make a better organization in your country or in developing countries. Thank you very much again. Well, now we are out of time, so exactly. So just I want to give just one chance if there is somebody want to say something. Okay, I will give you just a short time. I will give you.
Okay, thank you, Director. This was not part of the presentation, but just a quick one. I want to know what South Korea has for 6G in the future. What are the plans for 6G? Yeah, that's all. Thank you.
Thank you very much for your short question, but is there any presenter to give answer to his question? Or any government official to about the planning of 6G in South Korea? Okay, just maybe some government official give some brief answer to 6G. From the point of government, what policy? 과장님?
Director?
김 과장님.
I will speak in Korean. So actually, spectrum management, the policies are not ours from CRMS, so my answers might not be accurate. So I'd like to deliver the answers within my knowledge. So actually, there are candidate bandwidth for 711 for 6G. So this WRC 23, the Republic of Korea suggested that kind of bandwidth for spectrum for 6G, but actually standardization has not been carried out yet. As far as I know, by 2028 to 2030, those standardization for spectrum bandwidth will be completed. So in case of the Republic of Korea, 6G spectrum or bandwidth, actually we are not sure on the standardization and which bandwidth will be set and allocated. So if 6G becomes materialized, then there might be some spectrum usage in industries and service area. So what would be the implications onto those industries? These kind of implications are not well known, but we still are on the way of R&D for technology and building policies.
Well, okay, yes, please go ahead. Okay.
So, as Director Kim has mentioned on spectrum perspective, but in case of Korea, 6G standardization is underway. There are many industrial experts involved, and standardization efforts are heavy. And 6G communications up until now has been known to connection between the geostations and also satellite communications. So it recognizes the importance of LEO and 6G standards-based LEO business related R&D projects commenced this year. So by 2030, I do believe we will launch the 2 LEO So this is our goal, and R&D is rigorous these days.
Much for Mr. Kim for your additional explanation. Well, before I close up the meeting, the candidate frequency for 6G is starting and developing in I2R, working party 5D, and then we have to wait for WRC 27. The result, according to the result of WRC 27, and then we will make a decision, every country. Now, the frequency band and the operating characteristics are has been starting and still starting in working party 5D. So just to wait and see until the result of WRC 27. Thank you very much for your understanding. Well, so we are approaching to the allowed time, so I have to close up, and then really appreciate and thank you very much for presenters for your useful presentation, and also thank you very much the participants in floor for your questions and sharing the opinions and listening to some other people's some opinion. I will close up this meeting and have a nice evening. And I will close up this meeting. Thank you very much again.
Right, let's give another round of applause for our distinguished moderator and speakers, ladies and gentlemen. Right, so all of the program of today's Global Spectrum Management Forum 2025 has finally come to an end. Now, on behalf of the organizing committee, I would like to extend our sincere gratitude to each and every one of you for joining us here today and also for your valuable contributions. So we hope that these insights gained here today lead us toward a much brighter and a more cooperative future on the spectrum management. Now, also, I have some few announcements before we close up. Regarding the survey, we kindly ask all participants to complete the questionnaire you received upon entry or fill it out online by scanning the QR code displayed on the screen or scanning the QR code on your desk. If you have completed the paper survey, please submit it to the registration desk upon your exit. Your feedback is greatly appreciated. Also, lastly, we kindly ask all participants attending the dinner reception following the forum to gather at the lounge area right outside of the left exit. So thank you so much for joining us today and have a safe travel back home. This has been Sumin Yu and thank you so much. 네. 몇 가지 안내 말씀드리겠습니다. 참가자분들에게 보다 도움이 될 수 있는 프로그램과 포럼 만들기 위해 설문조사 진행 중에 있습니다. 현장에 참석하신 분들께서는 등록 시 받으신 설문조사지를 작성 후 퇴장할 때 등록 데스크에 제출해 주시기 바랍니다. 온라인으로 시청해 주시는 참가자분들께서는 화면에 띄어져 있는 QR코드 스캔하시면 설문조사지 확인하실 수 있습니다. 여러분의 소중한 의견 기다리겠고요. 아울러 포럼에 이어 만찬에 참석하시는 분들께서는 왼쪽 출구를 통해 연결된 라운지 그리고 또 스텝 안내에 따라 차례로 이동해 주시기 바랍니다. 차량 탑승은 코엑스 북문에서 탑승할 예정입니다. 네, 여러분 오늘 함께 해주셔서 감사드리며 모두 조심히 귀가하시기 바랍니다. 감사합니다.